Hello Taiwan, greetings from South Asia Bamboo Foundation India. We are happy to collaborate with the National Changchun University of Taiwan to collaborate and develop the R&D on bamboo sector. We are happy that we like to come to Taiwan and work together on this important subject.
因为竹子从以前大家可能思维上说它是一个比较老旧的东西，然后年轻人也认为说它好像是有点跟时代脱节的产物了。所以我们在看这个竹子的时候，其实就想要让竹子赋予新生命，它才会有新价值。特别是这个环保议题的抬头以后，那我们的倡议是以竹代塑。那传统的竹子的话，它可以应用的，除了竹笋吃以外，竹建材以外，一种就是把它碳化裂解以后产生竹炭跟竹醋液。所以这边我们在研究的是说，怎么样可以快速的让竹子裂解，然后以机械化的方式产生的这种竹炭芽，可以快速的成为一个以后竹农如果它产生竹炭商品的时候的一个环境。竹炭，像这样的，这是比较高精密的哈。这个也可以，你可以拿整个进来烧，因为我们在自己的机械窑的控制就很好，所以有些人就烧成变成叫竹炭杯，会有远红外线、热能的功能，可以活化相关的水质。那竹子如果烧成竹炭以后，再就是这种竹醋液，做面膜、杀菌用的，有做黄纹液，就是我们希望说我们所研发的东西，不只是你很有产值，而且是对这个社会或对地球真的很有贡献的。
我们一直认为说，未来的创意来自在地。
从最原始的怎么烧竹炭以后起步，到我们这些原材料以后，不同领域的老师进来会赋予它很多新的生命。
以前没有什么所谓的这个水管嘛，我们都是用竹子，里面打个洞接，非常好。竹子本身就是对周族来讲的话，它是一个非常好的一个东西。我们以前的家里都是用竹子来搭建的。
那我们一开始，我到5年前就已经来达拉伊谷。那刚开始我们跟族人有一些讨论，如何把他们在地的文化，特别是他们这边的土地的价值，可以做一个彰显。因为刚开始达拉伊谷它的成名是在于它的生态，就它生态很有名，很多的景点，然后吸引很多观光客过来。可是在这个过程当中，我发现它每天的这个团进团出，对它的旅游不是一个长远的一个发展。所以我们是不是可以从本土的一个价值或者它的文化里面做出发，去找到一个可以变成比较体验、比较有故事性的一个深度的游程。
我们这边产很多竹子，但是我们竹子就是采笋而已嘛，比较没有运用在体验的部分。
一开始不熟悉嘛，我们社区地方的干部好像不太能够接受，大家都觉得不可能啊，会觉得好像是不是要做竹炭的产品的竹子是要不一样的竹子，其实不是后来就慢慢认识之后，就觉得说它其实可以有别的产值。
因为竹炭除了净水，它还可以除臭。在都市里面，他们养猫养狗，它那个就会有这个臭味的问题。那竹炭的臭味的这种，可以变成一个竹炭的除臭包。所以竹炭的除臭包相对之下也达到一个环境的效果。
我们的学生进来以后，跟他们有一种创意的激发。对于现代的这个新世代的这个学生来讲，可能在学校4年、6年没有任何在地的经验，可是透过这样的一个往来，这样一个深度的一个交流，其实他们在学校上他们会带走这样的一个深刻的经验，对他未来在他的职场或者是在他未来的生命里面是一个很深刻的一个经验。长老跟我们分享，他们小时候如果想要吃鱼的时候，就带一把刀，然后沿路有那个竹子，然后一砍，刀子削一削，它就可以削出一个类似这样的一个鱼桶，然后绑一个绳子，他们就背着这个鱼桶就到河里面，然后呢用鱼叉，他们原有的鱼叉，然后就可以去叉鱼，然后他们很有智慧，他们长老。
Hello Taiwan, greetings from South Asia Bamboo Foundation India. We are happy to collaborate with the National Changchun University of Taiwan to collaborate and develop the R&D on bamboo sector. We are happy that we'd like to come to Taiwan and work together on this important subject.
因为竹子从以前大家可能思维上说它是一个比较老旧的东西，然后年轻人也认为说它好像是有点跟时代脱节的产物了。所以我们在看这个竹子的时候，其实就想要让竹子赋予新生命，它才会有新价值。特别是这个环保议题的抬头以后，那我们的倡议是以竹代塑。那传统的竹子的话，它可以应用的除了竹笋吃以外，竹建材以外，一种就是把它碳化裂解以后产生竹炭跟竹醋液。所以这边我们在研究的是说，怎么样可以快速的让竹子裂解，那以机械化的方式产生的这种竹炭芽，可以快速的成为一个以后竹农如果它产生竹炭商品的时候的一个环境。竹炭，像这样的，这是比较高精密的哈。这个也可以，你可以拿整个进来烧，因为我们在自己的机械窑的控制就很好，所以有些人就烧成变成叫竹炭杯，会有远红外线、热能的功能，可以活化相关的水质。那竹子如果烧成竹炭以后，再就是这种竹醋液，做面膜、杀菌用的，有做黄瘟液，就是我们希望说我们所研发的东西，不只是你很有产值，而且是对这个社会或对地球真的很有贡献的。
我们一直认为说，未来的创意来自在地。
从最原始的怎么烧竹炭以后起步，当我们这些原材料以后，不同领域的老师进来会赋予它很多新的生命。
以前没有什么所谓的这个水管嘛，我们都是用竹子，里面打个洞接，非常好。竹子本身就是对周族来讲的话，它是一个非常好的一个东西。我们以前的家里都是用竹子来搭建的。
那我们一开始，我大概5年前就已经来达拉伊谷。那刚开始我们跟族人有一些讨论，如何把他们在地的文化，特别是他们这边的土地的价值，可以做一个彰显。因为刚开始达拉伊谷它的成名是在于它的生态，就它生态很有名，很多的景点，然后吸引很多观光客过来。可是在这个过程当中，我发现它每天的这个团进团出，对它的旅游不是一个长远的一个发展。所以我们是不是可以从本土的一个价值或者它的文化里面做出发，去找到一个可以变成比较体验、比较有故事性的一个深度的游程？
我们这边产很多竹子，但是我们竹子就是采笋而已嘛，比较没有运用在体验的部分。
一开始不熟悉嘛，我们社区地方的干部好像不太能够接受，大家都觉得不可能啊，会觉得好像是不是要做竹炭的产品的竹子是要不一样的竹子，其实不是后来就慢慢认识之后就觉得说它其实可以有别的产值。
因为竹炭除了净水，它还可以除臭。在都市里面，他们养猫养狗，它那个就会有这个臭味的问题。那竹炭的臭味的这种，可以变成一个竹炭的除臭包。所以竹炭的除臭包相对之下也达到一个环境的效果。
我们的学生进来以后，跟他们有一种创意的激发。对于现代的这个新世代的这个学生来讲，可能在学校4年6年没有任何在地的经验，可是透过这样的一个往来，这样一个深度的一个交流，其实他们在学校上他们会带走这样的一个深刻的经验，对他未来在他的职场或者是在他未来的生命里面是一个很深刻的一个经验。长老跟我们分享，他们小时候如果想要吃鱼的时候，就带一把刀，然后沿路有那个竹子，然后一砍，刀子削一削，它就可以削出一个类似这样的一个鱼桶，然后绑一个绳子，他们就背着这个鱼桶就到河里面，然后呢用鱼叉，他们原有的鱼叉，然后就可以去插。
Hello Taiwan, greetings from South Asia Bamboo Foundation India. We are happy to collaborate with the National Cheng University of Taiwan to collaborate and develop the R&D on bamboo sector. We are happy that we'd like to come to Taiwan and work together on this important subject.
因为竹子从以前大家可能思维上说它是一个比较老旧的东西，然后年轻人也认为说它好像是有点跟时代脱节的产物了。所以我们在看这个竹子的时候，其实就想要让竹子赋予新生命，它才会有新价值。特别是这个环保议题的抬头以后，那我们的倡议是以竹代塑。那传统的竹子的话，它可以应用的除了竹笋吃以外，竹建材以外，一种就是把它碳化裂解以后产生竹炭跟竹醋液。 所以这边我们在研究的是说，怎么样可以快速的让竹子裂解，那以机械化的方式产生的这种竹炭芽，可以快速的成为一个以后竹农如果它产生竹炭商品的时候的一个环境。竹炭，像这样的，这是比较高精密的哈。这个也可以，你可以拿整个进来烧，因为我们在自己的机械窑的控制就很好，所以有些人就烧成变成叫竹炭杯，会有远红外线、热能的功能，可以活化相关的水质。那竹子如果烧成竹炭以后，再就是这种竹醋液，做面膜、杀菌用的，有做黄瘟液，就是我们希望说我们所研发的东西，不只是你很有产值，而且是对这个社会或对地球真的很有贡献的。
我们一直认为说，未来的创意来自在地。
从最原始的怎么烧竹炭以后起步，当我们这些原材料以后，不同领域的老师进来会赋予它很多新的生命。
以前没有什么所谓的这个水管嘛，我们都是用竹子，里面打个洞接非常好。竹子本身就是对周族来讲的话，它是一个非常好的一个东西。我们以前的家里都是用竹子来搭建的。
那我们一开始，我到5年前就已经来达拉伊谷。那刚开始我们跟族人有一些讨论，如何把他们在地的文化，特别是他们这边的土地的价值，可以做一个彰显。因为刚开始达拉伊谷它的成名是在于它的生态，就它生态很有名，很多的景点，然后吸引很多观光客过来。可是在这个过程当中，我们发现它每天的这个团进团出，对它的旅游不是一个长远的一个发展。所以，我们是不是可以从本土的一个价值或者它的文化里面做出发，去找到一个可以变成比较体验、比较有故事性的一个深度的游程？
我们这边产很多竹子，但是我们竹子就是采笋而已嘛，比较没有运用在体验的部分。
一开始不熟悉嘛，我们社区地方的干部好像不太能够接受，大家都觉得不可能啊，会觉得好像是不是要做竹炭的产品的竹子是要不一样的竹子，其实不是后来就慢慢认识之后，就觉得说它其实可以有别的产值。
因为竹炭除了净水，它还可以除臭。在都市里面，他们养猫养狗，它那个就会有这个臭味的问题。那竹炭的臭味的这种，可以变成一个竹炭的除臭包，所以竹炭的除臭包相对之下也达到一个环境的效果。
我们的学生进来以后，跟他们有一种创意的激发。对于现代的这个新世代的这个学生来讲，可能在学校4年、6年没有任何在地的经验，可是透过这样的一个往来，这样一个深度的一个交流，其实他们在学校上他们会带走这样的一个深刻的经验，对他未来在他的职场或者是在他未来的生命里面是一个很深刻的一个经验。长老跟我们分享，他们小时候如果想要吃鱼的时候，就带一把刀，然后沿路有那个竹子，然后一砍，刀子削一削，它就可以削出一个类似这样的一个鱼桶，然后绑一个绳子，他们就背着这个鱼桶就到河里面，然后。
Hello Taiwan, greetings from South Asia Bamboo Foundation India. We are happy to collaborate with the National Changchun University of Taiwan to collaborate and develop the R&D on bamboo sector. We are happy that we'd like to come to Taiwan and work together on this important subject.
因为竹子从以前大家可能思维上说它是一个比较老旧的东西，然后年轻人也认为说它好像是有点跟时代脱节的产物了。所以我们在看这个竹子的时候，其实就想要让竹子赋予新生命，它才会有新价值。特别是这个环保议题的抬头以后，那我们的倡议是以竹代塑。那传统的竹子的话，它可以应用的除了竹笋吃以外，竹建材以外，一种就是把它碳化裂解以后产生竹炭跟竹醋液。所以这边我们在研究的是说，怎么样可以快速的让竹子裂解，那以机械化的方式产生的这种竹炭芽，可以快速的成为一个以后竹农如果它产生竹炭商品的时候的一个环境。竹炭，像这样的，这是比较高精密的这 这个也可以，你可以拿整个进来烧，因为我们在自己的机械窑的控制就很好，所以有些人就烧成变成叫竹炭杯，会有远红外线、热能的功能，可以活化相关的水质。那竹子如果烧成竹炭以后，再就是这种竹醋椅，做面膜、杀菌用的，有做黄蚊液，就是我们希望说我们所研发的东西，不只是你很有产值，而且是对这个社会或对地球真的很有贡献的。
我们一直认为说，未来的创意来自在地。
从最原始的怎么烧竹炭以后起步，当我们这些原材料以后，不同领域的老师进来，会赋予它很多新的生命。
以前没有什么所谓的这个水管嘛，我们都是用竹子，里面打个洞接，非常好。竹子本身就是对周族来讲的话，它是一个非常好的一个东西。我们以前的家里都是用竹子来搭建的。
那我们一开始，我到5年前就已经来达拉伊谷。那刚开始我们跟族人有一些讨论，如何把他们在地的文化，特别是他们这边的土地的价值，可以做一个彰显。因为刚开始达拉伊谷它的成名是在于它的生态，就它生态很有名，很多的景点，然后吸引很多观光客过来。可是在这个过程当中，我们发现它每天的这个团进团出，对它的旅游不是一个长远的一个发展。所以，我们是不是可以从本土的一个价值或者它的文化里面做出发，去找到一个可以变成比较体验、比较有故事性的一个深度的游程？
我们这边产很多竹子，但是我们竹子就是采笋而已嘛，比较没有运用在体验的部分。
一开始不熟悉嘛，我们社区地方的干部好像不太能够接受，大家都觉得不可能啊，会觉得好像是不是要做竹炭的产品的竹子是要不一样的竹子，其实不是后来就慢慢认识之后，就觉得说它其实可以有别的产值。
因为竹炭除了净水，它还可以除臭。在都市里面，他们养猫养狗，它那个就会有这个臭味的问题。那竹炭的臭味的这种，可以变成一个竹炭的除臭包，所以竹炭的除臭包相对之下也达到一个环境的效果。
我们的学生进来以后，跟他们有一种创意的激发。对于现代的这个新世代的这个学生来讲，可能在学校4年6年没有任何在地的经验，可是透过这样的一个往来，这样一个深度的一个交流，其实他们在学校的时候，他们会带走这样的一个深刻的经验，对他未来在他的职场或者是在他未来的生命里面，是一个很深刻的一个经验。长老跟我们分享，他们小时候如果想要吃鱼的时候，就带一把刀，然后沿路有那个竹子，然后一砍，刀子削一削，它就可以削出一个类似这样的一个鱼桶，然后绑一个绳子，他们就背着这个鱼桶就到河里面，然后呢用鱼叉，他们原有的鱼叉，然后就可以去叉鱼，然后他们很有智慧，他们长老是一只手，你可以用这样，你就可以把鱼放进来。
我们那时候想说里山跟里海这个一个从嘉义这边是从山到海的一个平原线，所以我们那时候在想着说海边这边可以做什么。现在已经禁止抽地下。
Hello Taiwan, greetings from South Asia Bamboo Foundation India. We are happy to collaborate with the National Cheng-Chung University of Taiwan to collaborate and develop the R&D on bamboo sector. We are happy that we would like to come to Taiwan and work together on this important subject.
因为竹子从以前大家可能思维上说它是一个比较老旧的东西，然后年轻人也认为说它好像是有点跟时代脱节的产物了。所以我们在看这个竹子的时候，其实就想要让竹子赋予新生命，它才会有新价值。特别是这个环保议题的抬头以后，那我们的倡议是以竹代塑。那传统的竹子的话，它可以应用的除了竹笋吃以外，竹建材以外，一种就是把它碳化裂解以后产生竹炭跟竹醋液。所以这边我们在研究的是说，怎么样可以快速的让竹子裂解，那以机械化的方式产生的这种竹炭窑，可以快速的成为一个以后竹农如果它产生竹炭商品的时候的一个环境。竹炭像这样的，这是比较高精密的这个也可以，你可以拿整个进来烧，因为我们在自己的机械窑的控制就很好，所以有些人就烧成变成叫竹炭杯，会有远红外线、热能的功能，可以活化相关的水质。那竹子如果烧成竹炭以后，再就是这种竹醋椅，做面膜、杀菌用的， 有这黄文义，就是我们希望说我们所研发的东西，不只是你很有产值，而且是对这个社会或对地球真的很有贡献的。
我们一直认为说，未来的创意来自在地。
从最原始的怎么烧竹炭以后起步，到我们这些原材料以后，不同领域的老师进来会赋予它很多新的生命。
以前没有什么所谓的那个水管嘛，我们都是用竹子，里面打个洞接，非常好。竹子本身就是对周族来讲的话，它是一个非常好的一个东西。我们以前的家里都是用竹子来搭建的。
那我们一开始，我到5年。
The event will start in minutes. Remember to turn and switch your device into silent mode. Thank you. Good morning, good afternoon, ladies and gentlemen. Welcome to 22 Taiwan-India Global Bamboo Tech Forum Series 1, International Standards of Construction. We are excited to celebrate cooperation between SABF and CCU, our USR Bamboo and Bamboo Charcoal produced our host and guest today. We are very delighted to invite Taiwan Chair Dr. Jack Huang, the Director of E-Manufacturing and E-Commerce Center from Taiwan National Zhongzhen University, to give us his welcome messages. Ladies and gentlemen, now let's welcome Taiwan Chair Dr. Jack Huang. Dr. Jack Huang, please speak. Dr. Jack Huang, please turn on your microphone.
Okay, thank you. Thank you for all of you to attend the 2022, the 2022 first time of the Taiwan-India Global Bamboo Technology Forum. This is a wonderful time for the bamboo years. In Taiwan, we have invented several new bamboo technology products which can be combine strong part electronic equipment with the bamboo, such like bamboo air condition, bamboo air forum, bamboo charcoal waters, bamboo charcoal cups, etc. So in Taiwan National Zhongzhen University, we are the one of the most advanced technology to research in the bamboo, especially join the bamboo with several technology together. So this is a wonderful time. I like to invite all of you to attend the wonderful event. And I also like to thank my longtime partners, my bamboo, Mr. Bamboo, Mr. Kemash Salam. We are working together for last couple of years, especially during the COVID-19. We still became a strong team to promote the bamboo in the different part of the world. And I would like also thank you all of the people to attend today the forum or the workshop, and also our VIP guests and our speakers. Thank you for all of you to support the bamboo world. We like make this become a platform to link Asia and all part of world, and we all love bamboo. We use it to promote the bamboo, this natural materials to the world. Thank you. So I would like next ask the Mr. Kemashi Salam to give a few words.
Yeah, namaskar. Good morning, good evening, good afternoon to all. I would like to welcome and the third year of the India Global Tech Forum. I think all of you or your countries where you belong, you're recovering from this deadly COVID disease, and we can be grounded this year to do different works on bamboo. The theme for this conference, for this webinar, has been very carefully. The popularity of bamboo is around the from Brazil, from Taiwan, who has done extensive work on bamboo. We'll be listening from them, and also we'll be hearing about the standards that has been practiced in bamboo. I'll be introducing them while they speak. As of now, I think I will not take much time, but I will also like to thank our Taiwanese counterpart for working with us very closely. We believe in new technologies, we believe in new inventions, we believe in innovations. South Asia Bamboo Foundation has just signed MOU with Manipur Technical University in Imphal to carry out a lot of work in the state of Manipur and northeastern states, particularly in the area of human resource development, skill development, and many other areas. Particularly, we are also starting a bamboo innovation and incubation center in Imphal. So we are lined up with different works to do during these good days that are coming up. Also, I would like to also share that one of my first friends from Taiwan, who has worked with me more than 20 years, Mr. Jackie Hong, the owner of one of the world's best bamboo engineering or bamboo machinery, has recently passed away in January. He has left a big vacuum in the bamboo industry. His machines are seen all over the world, starting from Guatemala to Costa Rica to in fact, Jackie's father started this unit in Taichung. Now, Dr. Jack, I think that we should focus in one of our meetings about Jackie Hong's departure, death. It's a very bad, starting here when we heard the news about his demise. Anyway, we in the bamboo fraternity has to carry on our good work. And without taking much time, I think I would like to welcome all of you. And I'll be introducing all the speakers while they speak. So thank you, Jack, again, and I leave it back to you. Please unmute.
Thank you for Mr. Kemash. I'm also so sad to know the Jackie Holmes for his passed away, and we have some project work together, especially for the bamboo machinery. Definitely, we like to make some of the link with his son and try to see how we can work for the bamboo world. Next, I would like to introduce one of our VIP for open remarking, Dr. Senru Zhan. Dr. Zhan received his PhD from the United Kingdom of the Student Affairs in the National Zhongzheng University. He also is a previous director for the University Supervision Department in the government. So let us welcome for the Dr. Zhan for his opening.
Hello, everyone. This is Professor Shengyu Chen from National Chongqing University, currently as the Dean of Student Affairs. And I also want to extend my sincere gratitude to the conference chair, Mr. Kemash Salun, and also the co-chair, Professor Huang Shiming, National Chongqing University. Thank you for your kind invitation for this opening remarks. Welcome to India-Taiwan Global Bamboo Technology Forum. It is our major pleasure have a partnership from India to have this very meaningful and very innovative technological forum in bamboo particularly. I would like to say the collaboration between India and Taiwan have been very successful and fruitful because, as we know, bamboo is a universal resources for different purposes that have been widely used in the world, particularly in developing countries and tropical countries. There's so many bamboo, and that's the reason why we want to use bamboo as a very strategic and valuable resources to help to make this world sustainable. And the conference theme for this time, it will be Bamboo Construction International Standard. As we understand that bamboo have been used for lots of different construction projects and architecture, but the standard have been recently released in 2006, and for most of the people in this world, we are not so understand the standard. So the main thing of the bamboo standards for international conference would be very essential, not just only for Taiwan, but also for India and other major developing countries as well. With the new international standard for bamboo construction, I think it's quite beneficial for the whole world. Many agriculture and construction projects need the standards. So with this conference, we want to introduce the standards for everyone in the field. So I think the thing is so important. At the same time, I would like to emphasize that there's some projects going on across the globe. The bamboo construction have been widely used, and particularly for developing worlds, I think it could be used for classroom, could be used for shelter, and also for some asylum seeker. They also can use bamboo to design their home, their family. So I think it is very sustainable materials and resources for the whole world. So let's welcome to understand the new standard and also the new construction designed and constructed by bamboo. Thank you.
Let me introduce, hello, please.
Mr. Kamesh, please speak. Thank you.
Now I'd like to call upon the Vice Chancellor of Manipur Technical University, Dr. Bhaveshwar Tongbram. He is a PhD, MTech and BTech, a fellow of India Engineers. He is a chartered engineer by profession. He was a Deputy Director of Technical Education, Government of Manipur, and also held various posts in the Government of Manipur, such as Principal of Polytechnic, Engineering Research Projects, Member of International Network for Traditional Building Architecture and Urbanization, Member of International Council of Monuments and Sites, Member of Indian Society for Technical Education, etc., Indian Red Cross Society, Ramakrishna Math and Mission, Vidya Bharati, Akhil Bharatiya Shiksha Sansthan, etc. I would like to call upon Dr. Bhaveshwar to kindly give his inaugural speech.
Very good morning.
You are not visible. Can you put on your picture?
Yeah.
Yeah. Please put on your video. Yeah, please. Thank you. Yeah.
Okay.
Yeah.
Very good morning from India. Dr. Bhaveshwar Tongbram, the Vice Chancellor of Manipur Technical University. I'm very glad to be interacting with all the experts and panelists and other members from the CC, Taiwan University, and other members of the Bamboo Mission Foundation and other panelists, experts, and students who have joined this webinar on bamboo standardization in construction. So Manipur Technical University, we have established this thing, IIC, Institutional Innovation Council, with the AICTE, that is the Central All India Council for Technical Education. And we have started also the startup incubation cell with the government of Manipur. And we have started with this thing, Southeast Asia Bamboo Foundation, Mr. Kames Salam, to initiate the Bamboo Technology Incubation Innovation Center at the MTU. Because we are establishing a new campus with 116 acres of land for the Manipur Technical University, and all the design and the technical know-how will be intervened with the bamboo technology as an initiative in this region. And we have, since we know that this bamboo India is the second largest cultivator of bamboo, and Northeast especially is the biodiversity hotspot. And Manipur as such lies in the center of this biodiversity. And the species which are available in this region need to be harvested. It has to be researched, and it has, since we know this story of the Henry Ford in 1900, that his small innovation of this thing, standardization of his assembly, reduces that 1,200 hours of modeling assembly of his car to only 2.5. So we need standardization. So India as such, we have been having this thing, the standardization of the bamboo related this thing in construction, in material, in preservation, and in testing also since 1973. And since we need more standardization, we need more research, and we need more specification on this bamboo technology, bamboo design in other spheres, in limit state sphere designs. Besides that, since India is a very, very vast country, and the regional diversity is very, very fast. So like other construction materials, we need the zoning of bamboo also in that specification and the standardization. So today's international standard of bamboo in construction, that is Taiwan-India Global Bamboo Tech Forum and Series 1, today's webinar, is very much need of the hour. So I like to appreciate who have initiated this webinar and this tech forum series, Mr. Kames Salam and Jack Huang and others from the Taiwan University also. So I really look forward to working with the other design centers, to look forward all the organization and other institutes and the universities for resource sharing, incubation, innovation, and any technological know-how sharing in research, even in students and with the faculties. Since ours is a technical university in this region, and we have a very vast and long history of traditional bamboo construction in Rattan also. So we need to enhance the research and the design technology. We have to have the standardization in today's webinar. We have many experts and panelists who will be speaking on the standardization in different spheres of bamboo technology, design, and the material, and others, testing and seasoning also. So we look forward that such webinar will help further in enhancing this movement of bamboo technology and this movement of increasing the research and increasing the know-how and increasing the inclusivity in the ground level to the artisans, to the workers, to the architects, to the engineers, to the owners, to the contractors, and to the cultivators also. So we look forward with the seminar. It will be an initiation, since it is the first series for the bamboo text using forum. So we look forward again. So from my side, from Manipur Technical University side, thank you very much.
Thank you so much, Vice Chancellor Dr. Bhabeswar Tongbram. Now we would like to start our program. We have a speaker all the way from Brazil. I think it is 2 a.m. in Brazil. I would like to invite Professor Normando Perajo Barbosa. He is a civil engineer in the University of Pernambuco, Brazil. He has worked in many areas in the field of bamboo and and 150 publications besides book chapters, coordinators of laboratory works, testing materials structures where research and consulting works are done. He was responsible for many programs of replacement of more than 30 sub-habitations in sandy towns using compressed earth blocks and adobes. It renders voluntary service to the community. His work has already been shown in network in Brazil TV and many other channels. So I would like to invite Professor Normando. Professor Normando, if you can please join.
Yes, but I needed you finish.
Yeah, we finished. Please, Dr. Normando.
Let's see if it works. You have to invite me.
Yeah.
No,
Can you just arrange his? Can you arrange him to share his video?
it says that I can share
Please,
it.
we'll just work it out. Kevin, can you please help
if
him?
you needed to be, I became a presenter.
Yeah. Jack, can you just help him out?
Okay.
Yeah.
Do
Okay.
you see?
Okay, thank you, Normando. Please start. Yeah.
It's okay?
It's pray.
Good morning, good afternoon, everybody around the world. Firstly, I would like to thank Mr. Kamesh Salam the invitation to participate of this interesting event. I will talk something about bamboo in Brazil and something about the standards we have. I work for the Federal University of Paraíba. People living here, and then we have a lot of beautiful and pleasant beaches. Well, talking about bamboo in the 21st century, with so much technological development, one reason Earth is a finite planet. Another reason, industrialized materials has as characteristic high energy consumption. If we see the temperatures needed to fabricate them, we can see that these industrialized materials have incorporated a lot of energy. In a finite planet, energy has been the cause of international conflicts created by the dominant countries that need to ensure their futures based on energy. One more reason is that the world population is arriving at 80 billion of people. Besides food, all these people need home, infrastructure, energy, etc. But the earth is finite. And the current way of life is the actual capitalism, very cruel. It requires a lot of the earth. It's a system based on consumption, on infinite growth. This system needed for large-scale production, and it goes against a common sense on a finite planet. This capitalism has no brakes, no limits, and the accumulation of goods is part of this. Extreme inequalities necessarily arrive on a finite planet. But what does bamboo have to do with this? While industrialized materials consume a lot of energy, bamboo consumes solar energy. While industrialized materials consume non-renewable raw materials, bamboo is a renewable materials. While industrialized materials degrade the environment, bamboo restores degraded areas. While industrialized materials release a lot of CO2 and other contaminants in the atmosphere, bamboo absorbs CO2. While industrialized materials generate waste that damage the environment, bamboo is biodegradable. Its residues can be reincorporated easily in the nature, even be reused. While industrialized material require a complex installation to be produced, sophisticated technology, bamboo is easily produced by nature. While wood takes a long time to grow and be used, bamboo grows quickly, and plantations has continuous use. While industrialized material have good mechanical properties, also bamboo has good properties. Bamboo can replace a lot of products. Bamboo can replace plastic. As we can see, we know that there are more than 5,000 products made with bamboo. And in South America, there are a very large quantity of bamboo between Brazil and Peru in the middle of Amazon forest. More than 4 million of hectares in this area. In Brazil and other Latin American countries, the destruction of original forests are increasing. We intend to introduce bamboo as the main great contribution to the knowledge in Latin America and all the world was the architect, Colombian architect Oscar Hidalgo. His last book was Bamboo, the Gift of the Goods of the Gods. In Brazil, we started the first systematic in Brazil, there are autochthonous and exotic bamboo species. Great diversity, bamboo from a few centimeters and more than 30 meters. Exotics are the most used in architecture. Then Peru in 2012, Ecuador 2017, Brazil 2020. In Colombia, standard deals with police considering only guadua species. All this, as this standard refers only to guadua, it already indicates the alloy in the material. We have here in deflection, traction, compression parallel, compression perpendicular, and shear. Over this stress, a series of attenuations etc. For me, an exaggeration the number of questions. Concerning always guadua. And guadua angustifolia. Peruvian stand, in addition to the structure, presents a model of one this kind of there are a lot of information about bamboo walls, as you can see this type of wall. In the Equatorian stand, in addition to bamboo polish structure, also deals with bamboo wood panels. So there are many that details given about the panels. And bamboo wood panels a big standard they have in Ecuador. In Brazil, we have three standards. Of partial coefficients and limit states. So the characteristic strengths are obtained by mechanical tests, and the compression strength, as the compression strength is the easiest to obtain, the standard relates the other mechanical properties to it. So tensile characteristical tensile strength, we can say it's 1.1.3 compression strength characteristic com compression strength parallel to fibers, and shear and compression perpendicular, flexion and ion modulus. Design stress, it modifies the characteristic stress by two coefficients. This related to materials, it depends on the solicitation, and this other is to consider the type of load, humidity, quality of the poles. This one is for beams. To control quality, 13 steps must be taken from at least 6 different cúmulos per batch of a maximum of 250 stems. The Brazilian standard presents also the formulation to calculate columns, beams, etc. In the annex, there is information on connection between structural elements. In some connection, it's recommended to fill the internodes with mortar, as you can see here. Concerning determination of physical and mechanical property, it's similar to the other Latin American standards and ISO standards. We just made some small simplifications. The third standard, bamboo poles for structural use, harvesting, immunizing treatment, classification by diameter. It gives some information about how to select the comb, how to dry, how to treat, how to transport. The intention of this standard is for bamboo to be used, and the consumer is assured that the material was harvested at the proper age, treated and dried properly. Insect treatment is mandatory. Really, this is called Asian tiger. Insects completely destroy the bamboo and the bamboo structures. To protect the extremity of the comb, a good idea is to use a PET bottle and hot air. This protect the bamboo. Grading by diameter, we want to bamboo poles can be commercialized with lengths of 3 meters and 6 meters. So it's interesting to fix that the difference between the biggest diameter and the maximum diameter and minimum diameter is limited to guarantee that Conicity of the bamboo is in accordance with the standard of design of bamboo structures. And also, the covering of bamboo is limited as this value. Some bamboo construction in Brazil, the biggest one is in the Cultural Center Max Fever in São Paulo, Recreation Center in Amazonia, a Bio-Bamboo is an ecological school where bamboo building is taught. Celina Llarena is the director, which has built a lot of interesting construction using bamboo. We can see here several construction from Celina. For using bamboo. What is market here in Brazil? So here is a gym at the Catholic University of Rio de Janeiro, made by this group. And interesting, they use only this. This is not a temporary construction, not a temporary construction, but they use this type of connection. This type of connection. This was made at the university, base stop in bamboo. Some in Brazil of heat treatment. We have here behavior under heat treatment of bamboo. We can see even temperature close to 150 degrees, bamboo stick retain their properties. At the beginning, in the years 18, we started to study bamboo, and the idea was to reinforce the concrete beams. But we have a lot of tests, but the performance is not very good due to the low models of elasticity of bamboo, which can be half of the concrete. And we study also bond strength, bamboo concrete, durability of bamboo as concrete reinforcement, and concrete beams wall with bamboo. The maximum load is significant, but showed an almost brittle break. It's not interesting to use concrete bamboo as reinforced material. Small gypsum beam reinforced with bamboo. This prototype, we used here this kind of small beams. And since 2008, went out pathologies. Interesting way to use bamboo is a permanent bamboo formwork, for example. In steel, we have special connectors. In bamboo, we have natural connectors. So we can use half of the cum and concrete, and we have a good floor. It performs very well, but it is very flexible. But for normal loads, it works. Well, bamboo also was studied. Development of connecting elements and the metallic elements for connections. The idea to use big blocks using microconcretes and cement, sand, this kind of microconcrete. Pieces of bamboo are placed in the formwork. The microconcrete completes the block, and there is an easy and fast construction you can do with using this. The first prototype from 2004. We started to study long panels. Use this high load battery capacity is incredible. To 20 tons here in the top of this impact test of the body impact. As you can see, the test of the high maximum load capacity, 37 tons by meter. Bending test, thermal test, and bamboo microstructure. Everybody knows that that are the vessels here. You are studying to the impregnation of the vessel with polymeric resins to put here some product. It works for the impregnation with resin is not easy. It's very difficult. We arrived to impregnate small pieces until now. Small pieces. We need to improve the method to have long pieces of bamboo impregnated. But it works very well against insects. Well, the future of bamboo in Brazil is promising. We have a Rede Brasileira do Bambu, national network of research and technological development integrated by researchers, technicians, and professionals of universities and research institutes. It's necessary to have material available. Production of seeding and plantations is necessary. As Brazil is very large, plantations are needed in all the regions to avoid long distance transport. There are currently numerous WhatsApp groups, bamboo groups in Brazil. And we repeat, the future of bamboo in Brazil is promising. Of this, there is still a lot to do to spread it. We hope it will change the reality of many people in the country, including those who need land and don't have it. For example, these are cases of extreme poverty from people landless. They live inside the bamboo plantations and do not know how to use and exploit this material. The intention is to organize a course of the use of bamboo, and hence bamboo can also contribute to improving living conditions in many people in Brazil. Thanks very much for your attention.
Thank you so much, Fernando. It has been a wonderful presentation, and I look forward for more collaboration with Brazil, especially in construction. Your expertise are wonderful, and thank you so much again to speaking at the midnight in Brazil. Thank you so much. Thank you.
Thank you so much. Very good speech.
Thank you.
I would like to call upon the next speaker. He is Mr. Kevin. Roland is an expert in construction technology, disaster recovery, and operating human settlements with the United Nations. He was instrumental in developing housing for the largest refugee camp in the world, that is in Bangladesh, Chittagong. Kevin excels at oversight of building operating temporary settlements. He thrives when developing deployment on short notice into complex scenarios. With minimal information, he supports teams from many positions by fostering teamwork to build a plane while in flight. In 2004, he co-founded the Natural Builders, a licensed general construction company, combining his passion for sustainability and commitments to improving the lives of beings. His license in international building codes, contract laws, and committed to quality assurance. Kevin Royal grew up in Michigan and a teenager moved to California to be Zen monk. After years of organic farming and starting a wall, he decided to get off his cousin and try to help the people. I would like to call upon Kevin, please.
Thank you so much, Kamesh, and everybody. Can you hear me okay?
Yeah.
Beautiful. It's such an honor to be here and to share this space with so many colleagues, with so much incredible experience and such a depth of knowledge. Just start this. So Kamesh shared a little bit. Over the last 2 decades, I've gotten to be a part of many, many beautiful projects. As he mentioned, I was born in Michigan. My favorite color is green. And since I was a child, I have been obsessed with building out of sticks and stones and mud. This led to the founding of my company, the Natural Builders, in 2004, and has resulted in an incredible life, studying and working with masters of construction and community around the world. Many of those projects have centered around post-disaster recovery and efforts to improve traditional construction materials. And today I'll share a little story about some of those experiences. In August of 2017, violence unfolded in Myanmar as government forces engaged in what the United Nations and actually just yesterday here in the United States, the Biden administration would determine is genocide towards the Rohingya ethnic group, killing thousands and forcing them to flee to safety across the border in Bangladesh and far beyond. The people of Bangladesh opened their arms and received the refugees, establishing Kutupalong refugee camp as an extension of Balokali camp built decades earlier near Cox's Bazar. Cox's Bazar, a location popular with tourists for its long sandy beaches, quickly became the largest bamboo city. Aid agencies raced to provide shelter and food as over 800,000 people fled to safety. Flooded with need, refugees were provided only basic provisions for making shelters, including rope, tarp, bamboo, basic tools, and technical and physical support. Almost overnight, the world's largest refugee city took shape. Quickly, damage due to pests was recorded throughout the camps and the quest for solutions undertaken. Partners like the world-famous engineering firm Arup and the organization Humanitarian Bamboo and many others were critical in identifying the need for a more durable solution. My first deployment came with the American Refugee Committee and took me deep inside of Kutupalong and a picture of what was happening on the ground with the context of this camp. You can find this full report with the American Refugee Committee at naturalbuilding.com, my website. As a first step at improving the durability of the shelter, the United Nations International Organization of Migration established and ran a trial bamboo treatment facility near Cox's Bazar. For several months, they practiced using borax and boric acid in submersion, eventually treating about 300 bamboo poles per day. I joined as a consultant during this initial phase of testing, working in concert with other agencies and other international professionals, including our dear friend Kamesh's guidance and support. Seeing the success in this small venture, 300 poles a day, we boldly set out to expand the bamboo treatment facility from the trial size to a capacity of over 2,000 poles. As the facility infrastructure and quality assurance improved, so too did our ability to provide improved shelter for the Rohingya and the local Bangladesh community. As we did this, we realized we were having an incredible impact on the region's supply of bamboo. As we improved the process, we needed to improve the quality and quantity of material being delivered. Working closely with the Bangladesh Forest Research Institute's director, Dr. Mahabub Babar, the shelter sector leadership, and numerous partners, we set out to establish more universal standards. A team of us surveyed the regions where the supplies came from and traced the bamboo's meandering path to our facilities, studying the types of contact and engaging key stakeholders to understand how to embed quality assurance and reduce the negative environmental impact of over-harvesting bamboo. We took a multi-pronged approach, lowering the minimum material supply threshold for our contracted vendors, meaning they didn't have to just commit 1 million poles of bamboo, they could commit 40,000 or 10,000 poles. This allowed for more vendors to participate. We went from 4 main suppliers to over 14 main suppliers. The diversification created competition, but it also created better motivation by decentralizing the supply chain. Standards of trainings for awarded contractees allowed us to improve the explanation of technical requirements, diameter, age, etc. We quickly rose from a 40% material acceptance to well above 90%. The trucks came closer to the planned schedule and the pipeline was more secure. Now came the tricky part, finding a way to balance the system in the context of an emergency of scale never before seen. Too much material made the storage yards burst at the seam, and too little made distributions slow down. We had to control and influence what we could and also respect the things out of our control. As the system to process bamboo became more regular, we had to consistently improve on each step in order to reuse the liquids. For example, from treatment, we engaged with the environmental science team called HiFi Design Labs, creating protocols to manufacture charcoal from the offcuts of the bamboo. This charcoal would be turned into a filter medium. We can run the effluent or the liquid portion of the treatment solution through this medium to remove the dissolved organic carbons or the sugars that build up in the treatment tanks. By doing this, it allows us to not only reuse the water portion of the treatment liquid, but also the existent borax and boric acid content. Now, I will say this is a very complex piece of research, and it is still going on to this day. The research continues in collaboration with the Bangladesh Forest Research Ministry. They recently opened a central bamboo aspect training facility in Bangladesh, and this this facility has been continuing to support with technical advice to the IOM team. These efforts made to improve the living conditions for the residents of Kutupalong, as well as the nearby Bangladeshi community, they represent a massive effort and also only a small hint of what is to come as the world faces increased environmental and social fragility. With 90 million displaced people today, we must make rapid and drastic steps to assure that we reduce environmental and social risks globally. Just in the last 2 weeks, the number of people displaced has grown by over 7%. Just in 2 weeks. If an annual increase of 7% were to continue for the next 30 to 40 years, we will be at over 1 billion people displaced. Every time communities are displaced, it inadvertently affects another community's resources and ability to thrive. While bamboo will not solve the world's problems, this project showed us how powerful international collaboration in compassion with consideration of both the environment and the people can be. I want to send a special thank you to the incredible team of the International Organization of Migration in Bangladesh, its leadership, and each of the sectors and contributing NGOs. It is only in humanitarian work, it is only in this kind of radical collaboration that we can truly accomplish great things. The shelter cluster, my friends at the Bangladesh Forest Ministry, and so many amazing supporters and bamboo experts around the world. My mentor, Daryl DeBoer, Mr. Kamesh, of course, Jörg Stamm, so many names, so many friends who all jumped in and offered their frank advice during the review of the technical portions of this project. Anyone is interested, you can go to naturalbuilding.com. With the consent of the United Nations International Organization of Migration, we were able to publish multiple documents to help share openly what our process was. These processes are not final, nothing is final. We are truly committed to and hoping that people will be able to take the information of such a grand scale and make improvements. And if anyone has any questions at all or needs support, I am here for it. I am your brother in bamboo. So thank you very much for the precious opportunity, my friend. I'm so grateful to each of you and the incredible work you do. And my blessings on this conference. May its energy and merit go out into the world. Thank you very much.
Thank you, Kevin. Thank you so much for your nice presentation. We are very much touched by your presentation, and I hope that such projects will be there around the globe where we all can play together. Thank you so much, Kevin. Thank you.
Thank you. Thank you.
Thank you so much for the Kevin. It's a wonderful speech. Let us know how the big project, how it's success by using bamboo. We are so thankful for you to have a speech here. Next, I would like to introduce one of my good friends, Professor Yunxiang Chiu. Yunxiang Chiu is one of the members in Taiwan. We work together for we call University Social Responsibility Project. We are work together, and we also visit Europe to see how this is work in the world. Professor Chiu is get his PhD from the Carnegie Mellon University in Pittsburgh, USA. He is also a famous architect in the Pennsylvania, USA, and he worked for many projects in the bamboo. Actually, I just visited one of his projects, which he worked with and his student to build a bamboo construction in the outside my university. We call Zhuqi railway stations. Let us take the chance to welcome for the Dr. Chiu for his speech. That's for you, Dr. Chiu.
Thank you. Let me share my file first. Do you see it on the screen?
Yes, yes, we can see
Okay.
it.
Okay, so let me get started. First of all, I like to say the project Kevin sharing is so exciting. It reminds me my day when I work as an intern architect in Pennsylvania, attending this Habitat for Humanities project. Okay, so without further ado, allow me also to share my project here. Okay, so I'll just get started here. So thanks everyone to be here, and I'm glad to share the story of an artistic creation of an.
Dr. Jude, do you want to enlarge your screen?
Okay, let me try it again. Okay, do you see the full screen now? All right,
yes.
All right. Okay, so let me get started again. So this is an artistic creation of an bamboo installation project, and the name is Floating Cloud, and the title we call it, okay, the Floating Cloud, which we consider is modern interpretations of Taiwan's vernacular bamboo assembly techniques. Okay, so the presentation will be in the following order. First, we are talking about the floating car in exhibition, and then design concept, and then what we learned from the past, and then the construction and installation process, and also our search for the design freedom with this kind of construction systems. The floating cloud is one of the 6 student-built bamboo installations commissioned by the Taiwan Bamboo Society. And luckily, this project won the Golden Award for the invite-only competition. It is currently in exhibition in the Zhuqi train station, as Dr. Huang just mentioned. And these are the 6 projects being in the exhibition, and our project is right in the middle. And in the night, the floating cloud, we wanted to make it a temporary shelter for the cross-country traveler, or we call that Dabulong, Daluhan. It's a Bunong tribe's term of the hunter's hut. And we thought the warm lights from the interior invited the traveler for a cozy stay. And in the daytime, it is an outdoor furniture, or we could call that a big bamboo toys, if you may, that provides all kinds of human art-piece interactions, while the metal nuts shimmering under the blue sky. And so we could see some of our design interactions. One is in the button. You could use like this balance one, and you can standing on top and to find a balance point. And the other pass we can do is on the right-hand side, that it is actually a chair. You can sit at the end of this structure, and also you can climb up. And also we use the metal nuts. Actually, that is the scaffolding clamps as the reflecting dots to show the weather conditions in a way. And also, this is some of the photo we taken on site during the inauguration ceremony. And I'm especially proud of my students and colleagues in this project that they were not discouraged facing the outbreak of the COVID-19 and pandemic in Taiwan. And really, this is some challenge for us. The project begins when everything was fine. And then all of a sudden, there's a major outbreak. So all this design procedure, or even the things we are not allowed to go outside, and eventually we able to overcome all these challenges. So I think it is so much more rewarding to enjoy these fruits of our dedication under such hardship. Okay, so let's talk a bit about the design concept. In the very beginning, we have decided to make this project with two purposes, two folds. The first of all, we wanted to express our appreciation of place. The place that the exhibition takes place is in the Ali Mountain, all right? And then secondary, we also wanted to develop a craft systems which can be widely applied in real-world projects by everyday people. So we hope that it's beautiful outside, but it's fun inside. And let me begin with the artistic side, the expression of space. And there are plenty of bamboo forests in Ali Mountain. And so the bamboo is tall, bamboo is hollow, and bamboo is soft. And so through bending, the fibers on the perimeter of the bamboo cones is actually stressed and sustain its strength. And then the space under the bamboo forest is a manifesto of the biomaterials personality, if we may, right? It folded and then we got this kind of a Gaussian church-shaped space. So this is the foremost form shaping concept. We take it with our own bamboo work. And then the mass of the mountaintop of Ali Mountain is usually floating above the cloud. So it's also a common thing there. And so it is contribute to the massing of our bamboo design. We're trying to create somehow this something floating, a mass floating in the sky. Nature-wise, the imperial peasant Di Zhi, all right, that is the national bird of Taiwan, is a common residence in Ali Mountains. And so the white strips and the dots on its body as well as on its tails and wings is a very important sign that how people identify that they see the imperial peasant from a distance. So this is the same visual patterns that we wanted to carry with our floating clouds. Also, the other another indigenous species of Ali Mountain is this freshwater fish. We call that Taiwan Sojao carp, kuhua. All right. When the school of fishes feeds on the rock mounds, their body turns sideways, and then the sun shines through the water, and then they just like you see this shimmering under the sun. People are on top of the water. And again, this will serve as our image that we wanted to carry. And finally, to deal with the steep slope, the path of Ali Mountain Railway is arranged in a zigzag formation. And we further expanded the metal strip pattern to pay our tribute to this 100 years old mountain railway system, the only one in Taiwan. And this tribute also pay our homage to this beautiful landscape. So let me turn to the craft sites. Starting with this picture, a not so successful exercise of both and Thai traditional joint method. This was a project exercise done by my students. We know traditional architecture as well as bamboo crafts in Taiwan use a lot of this bolting method using bamboo sticks or use tie to fasten the structure. And then through students' practice, we understand both crafts require highly skilled craftsmen to do that. It's not like everyday people can do that en masse. And then with that basic understanding, we come back to the to think about the working properties of bamboo. The bamboo, in a way, there are, how do I put it? Bamboo, in a way, when we think about bamboo, we first think about steel pipe. there are similarities and differences between them. And the similarity are this above. They are both lightweight, they have very high strength to weight ratio, and they have high mass efficiency because all the mass are on the perimeter, which either be a tensile member or compression member play that role. And then it has very long effective working length. And in Taiwan, 4 meter per piece of bamboo, which is about a similar dimension, is quite easy to get. And for steel pipe here, our standard length is about 6 meters. But there are also significant differences between bamboo and the steel pipe. The bamboo tend to decay over time because it's a biomaterial. And then the dimension actually decrease over the length. For the button who close the root is actually wider, and then gradually you become thinner. And it has lower density. So if we're talking about the weight to strength ratio, bamboo and steel pipe are similar, but when you consider the dimension, because of the low density, the bamboo actually is much weaker. And the comb is made of nodes and internodes. So it's not a homogeneous structural member like pipe. So that we need to take into consideration. And because of its low density, it's highly bendable. It's highly bendable, and then also it's made of fiber, not kind of composition of fiber laying together rather than homogeneous atoms. So, and then also it has lower shear strength. So whenever you have penetration through the side, it very tend to split with the drilling, and then split through, creating the crack. And on the right hand side is the bamboo we are using. It's again an indigenous species, and it's also the kind of bamboo that Japan's kendo use for their fighting sticks, and makino bamboo. And it is a common construction material for traditional Taiwan's bamboo house, using as roof rack. And in the nature, its diameter range from 2 to 10 centimeter, but mostly based on our observation, is somewhere between 5 to 8 centimeter. And the pole or the could be up to 16 meter at all. But of course, the useful size, the useful length in our estimation is more or less around 4 meters. And then the internode, between nodes to node, somehow vary from 10 to 24 centimeter, but it's again more close to the 20 centimeter. And the specs we use for our this 6 centimeter diameter in average is chosen, and we also use a fire roast. On the left-hand side is like 10 centimeter away from what we want to do. Then we need to kind of untighten everything and then do that all together. And then in a very complicated or complex project, this will become almost impossible. And the second common method is this bowl through. And this example, they use metal bowls, but traditionally they use chopsticks kind of things to penetrate. And that created a point stress. And when we have point stress, and then without, even though if you have any outside force just to knock on the bowl and give it extra stress, the split will occur. So this is an example of how split occur. But once the split occur, they no longer able to hold it together, become no longer a complete piece. On the right-hand side, is the more conventional way. They use vise strip to tie the knots. But again, this requires a high skill set. And the other thing is that because both the bamboo and the vise strips are organic material, it will shrink over time. So the tie will become loosened. And in compensation, traditional construction method, they always put a wedge on the side. And whenever they loosen, you should just knock on the wedge to tie up these joints. And then let's take a look at the assembly. And so on the real housing, upper left-hand side, the picture, you will see this non-coupling assembly. The knots, vine ties, vine strip knots, actually they use grip rather than penetration. So the structure can hold there for a long time. The house we survey on the upper left corner is already 80 years old, and everything's still intact, although it looks a little bit old. And then that's same thing for roof rafter. They always, I mean, whenever there's a cross section or extension, the extension is on the upper left corner. That's the beam, right? This extension, and then this cross section is on the main beam of this rafter joint. They just don't work as coplanar. They always have a shift of these things. And then the second thing you notice is the low bearing post, which is the vertical posts. They don't necessarily want the most straight one. Sometimes they rather have this a little bit bended one. And as long as they are on the coplane of this low bearing plane. The reason being, we have checked with the old masters. They say sometimes the bamboo bands, you will have this inner stress, become more resistant to bending moment or other things. So this bending of the straight post itself also has certain characteristics that the reasoning behind why the old masters like to use that. The lower left corner, the picture is the modern scaffolding. And the scaffolding is made of pipe, steel pipe, but then use scaffolding clamps. And so again, that's non-coplanar assembly, but it allows this freedom of movement through rotation. So we learn from this and then really come up with our own development system. Is that the first is that for typical people, even for architecture students, it might not be easy that you, in each project, you make 200, 300 ties, perfect tie, or 300, 400, 200, 300 perfect vine knots. So grip is better than penetration, but we need to have something easier to make. So then we choose the scaffolding plan to replace the traditional knots systems. And in terms of times, it takes about 1 minute to fasten the clamp. It takes about at least five minutes to make a knot. And the other thing is that we could use this clamp to create it. One is the extension system, and the other is the rotation system. The extension, you only need to have two clamps to clamp on two posts. Then that would be the vertical linear extension. And then if we want to rotate that here on the right-hand side, if we have one clamp on side, then we could rotate that. So that gives you a freedom of expression, or freedom of form. And so once we have that understanding of what's going on, and we use that as our construction system. And so then let me share a bit about the the making of the floating cloud, which is actually two steps. One is the in-shop construction, and the second is the on-site installation. And I think the prefab, or we call in-shop installation, actually has its benefit because we have much better control of the quality as well as the needs. So this is our basic step. We start with the fire bending bamboo in the woodshop, which is in our university, a National Taiwan University, which is about 200 km away from the exhibition. And the first thing we learn is that since the purpose of bending is we need to lose the fiber, but there's a thickness in bamboo. The skin itself is actually more or less water repellent. So we found out the most important step to make it success is to make it fully soaked inside water. And what we do is that we sprinkle the water on the bamboo and then cover it with canvas overnight. And so now the bamboo itself is soaked with the water. And then we started to do this fire bending, which is on lower left corner. Fire bending is also a traditional skill set that used in our craft. And it's not so difficult. How do I put that? It's actually the craft is not so difficult once you know the key. Whenever you are overheated, you started to see these oily bubbles. I think is the white one. That means you are actually losing the fiber. And so just with very minimum use, the students can achieve a successful way of. And the other thing we find out is that the dried bamboo Okay, then once we have this bended bamboo, we started to try out how we are going to form, these floating cloud structures, and we try a couple forms, and the one on the right is the prototype. And after the prototype had been decided, we test the strength of the structure with our body weights. So I'm standing on top of the prototype on the upper left corner. And then once we have this prototype, the second thing we do is to further force span and lock the bamboo with the scaffolding clamp. So if you look at the picture on the bottom left corner, when the students do that, they actually someone forcefully to bend the bamboo further in the direction which already occurred further. So they have this pre-stress, and then we use the clamp. You use the scaffolding clamp to fix it, so the entire structure is actually pre-stressed, and so that bring about the rigidity that we needed for this structure. So the alignment of the scaffolding clamp is very important for the artistic expressions. And as we explained early on, we wanted to reflect the local, the sense of the place. So the V shape or the Z shape, speaking to the emperor pigeon, the national bird, or the railways patterns, that is very important. And these things happen coincidentally. One is for artistic creation, but the other is that whenever we want to overlap the bamboo to make its continuous curve, we do need to have two joints to make it expansion. So with these two joints and then with different kind of distribution, we can see from the left, from the middle, and then we were able to really achieve what we want to achieve in terms of its image. And then the finished size of the floating cloud is actually dimensions based on the size of the container of the cargo, but also that is the same thing about the size of the railways track, because they are all of the same systems. And then we ship it overnight from Taipei to Jiayi, which is about 200 kilometers more or less. And then the same group of students, they bring it to the platform of the railway cargoes. Now, the final step is on-site installation. And when we move it on-site, the first thing we do is to check all the joints. Are they still grip friendly? Are they still grip friendly? So there are a testing on the bottom left, and also reinforcement to fasten all the loosened clamps. But it's really interesting actually. In the beginning, we saw maybe 20% or 30% of the claim going to be loose because you know the transportation is tricky, especially go up to the mountain. And in the end, I think we only pick up maybe 4 to 5 scaffolding claim need to fasten out of this about 100 claims. So really the bending, the pre-bend of the bamboo give it a strength to hold the clamp all together. And then in terms of artistic expression, we want it to be detailed, right? So we use, again, traditional scaffolding method. We put 4 temporary poles on the side and use that as the lever and to adjust the tail angle. And then eventually we find a tail angle that we are happy with. And then also we are happy with. And I would say 2 minor steps I think is also worth sharing. We use the wider thread rather than metal steel tensils wire, because this wider thread has less cutting force, so that it's easy for people to work on without getting hurt. And then we put a crossbar to also edit a little bit of strength to make it very to increase the rigidity of the cross section. Okay, so after the completion of the project, we keep going on searching for design freedom, and by talking about design freedom, we are really talking about we try to find a craft system to be free from the orthogonal structure system of traditional bamboo house. As this one, it always has this orthogonal systems and roof rafter. So one case is this thing we call a dancing gate project. Is in an elementary school. We use double up bamboo post and the weight balance to achieve the structural rigidity. And the other example is the we call the Earth Triangle. It's a project for high school winter camp. Students want to study architecture to explore another form generation potential of this craft system. And I think it really proved that we can do on-site adjustment and with a very basic understanding with teamwork. It's a really an advantage for this craft system. Okay, so this concludes my presentation today. Thank you very much for listening.
Thank you for Professor Chu for his wonderful speech. Let me more understand how the design which you are working in the outside my cities. Thank you very much. Next, I would like to invite Kemash to take for the next speakers.
Let me thank you for the nice presentation. I would like to invite Mr. Priyam Goswami from Jorhat, Assam. He is the managing director of a company, architecture firm. And I would not like to take much time, but Priyam, I think you can start your presentation.
Yeah, thank you so much, Mr. Salam. I am really thankful to South Asia Bamboo Foundation and National Chung-Chang University, Taiwan, for inviting me to speak about my experiences on bamboo construction in Northeast India. Let me share my screen. Yeah. Is my screen visible to everyone?
Yeah, it's visible. Yes. Please enlarge. Yeah.
Yeah. Does it work?
Yeah.
Okay, great. So I'm going to speak very briefly about our experiences in bamboo construction, and I would like to focus on the bamboo construction that we have undertaken in public spaces, concentrated in the northeastern part of India. This is the region that we call the northeast of India for the information of all our international guests. And as you can see, the area is quite green in the map, and it actually is quite green. This is the natural landscape that we see all across northeast India. It comprises of hills and plains areas, and it's mostly quite green. It has a very high green cover. However, the urban landscape of the cities in Northeast India is quite in contradiction to what the natural landscape is. And there is a big disparity between the two. And we are trying to find a solution through bamboo, if possible. If bamboo can be used as a solution to uh, to this trend of industrial materials taking up the mainstream civil construction. We'd like to see if bamboo can be used in that. And to do that, our first objective is to make bamboo more visible and more acceptable to the people. Because bamboo nowadays is not a very glamorous material, although traditionally, since thousands of years, bamboo has been used for construction all across northeastern India, as it has been in other parts of the world where there is bamboo available. But of late, it has is gone out of trend. It doesn't seem the right material to work with because of many issues. But we are trying to bring bamboo back to the public visibility, and that is why we are trying to use bamboo in more and more public projects, public spaces, and public projects nowadays. So I'll talk about a workshop that we did in Arunachal Pradesh in 2018, where we had Yorkstem come over all the way from Colombia to teach us about his methods of bamboo construction. And this is in a place called Namsai in Arunachal Pradesh in Northeast India. And through this workshop, again, we are trying to create an awareness between amongst architects, architecture students, amongst local craftsmen, the government, and people from various sectors on the possibility and the potential of bamboo construction in a modern way. So I'm going to show you the progress of the workshop a little bit, and then we'll move on to a few other projects. Here we started with Dr. Akit Taj explaining to us about different species of bamboo and their usage. We talked about the grading of bamboo, how different types of bamboo could be used in different manners, and why the grading is very important. We talked about the treatment of bamboo by drilling it and then through this vertical dip diffusion technique, where the bamboo was kept upright on a tree and then borax solution was poured onto it, and thus the bamboo was treated. In this case, the bamboo that we are using was of Bambusa balkua, which is quite available in Northeast India, especially in Assam, and it is quite good for construction. The washing and cleaning of the bamboo was very important. Then there's Yorksem who was teaching us about the use of all the power tools and customization of those tools to fit our requirements here, about making the loops using nylon ropes. Then this is a sketch that York prepared for the structure that we were building. This was a tea pavilion that the head monk of the monastery at Golden Pagoda in Namsai, he had asked for a structure like this. And this is the sketch that York prepared. And then based on this, we prepared a computer model of the structure to get us the exact measurements of the bamboo pieces to be cut. This is the way we found out the exact measurements, and accordingly the bamboo was measured and cut. Yorksam also taught us the use of bamboo nails and how it can replace steel bolts in the construction. He helped us set up the workbench, and we started using these columns of bundles of 4, the beams using diagonal nails. We also created some bamboo models using sticks just for experimentation purposes. We had some fun as well. Created some interesting parametric structures to understand the modern usage of bamboo. We also started fixing the rebars to the columns for laying the foundation. This is how it was. All the measurements were done at site. The excavation was done. And then this is the treated bamboo being taken out from the diffusion tank. The frames were prepared, and these frames were so lightweight that they could be transported, by us participants carrying with our own hands. We transported them to the site and erected it there. This is how we did the erection. The levels were checked, and then the concrete was poured for the plinth. The alignment of the superstructures were ascertained, and then the frames were tied up. The structure was set up. This is the main frame of the structure that was done, and later on, this is a part of the structure that was done after the workshop was completed, because we had a limited amount of time. But then the thatching was done on the roof. This is the completed structure that you can see with all the thatch roof, and the plinth is in concrete. This is how the inside of the structure feels. It's very cozy, very airy as well, because it's open from all sides. It is a beautiful view. And these are some of the joineries that were done. You can see that we created some benches inside, and all the roof structure, the truss frames and everything were polished and maintained. Next, I'm going to talk very briefly about another workshop that we conducted in Manipur in 2019 as a part of World Bamboo Day. These are the participants. Again, here we had mostly local artisans and bamboo craftsmen who had participated in the workshop, were willing to learn about different building techniques with bamboo. And here our objective was to build a prototype for a bus shelter for the Manipur, for the Imphal Municipal Authority. And we had a time of 3 days to complete the structure. And this is, I guess this is Dendrocalamus hamiltoni that we used for the construction of the structure. Again, the process was similar: the grading of the bamboo, the removal of the knots, the measuring and marking, cutting to length of the structure of the bamboo poles using power tools, then washing the bamboo, float washing on a water body, then drying of them in stacks. Then we were erecting the scaffolding and then cutting the holes for the columns to pour the concrete in. This is how the columns were erected. Cross-cutting techniques and longitudinal cutting techniques for the joints. This is how we were creating the lap joints, cutting 2 pieces in 2 halves and then joining them together like that. We had short spans, so this kind of lap joints did work. But of course, for longer spans, we would adopt different techniques. So then again, drilling in the bamboo and fixing them with these stainless steel bolts and nuts. This is the primary structure that was erected, the fixing of the beams with the columns. And then we were fitting the primary rafters like that. So the roof structure was also done. Now it's time for the roofing sheet to be added. Here we were using this galvanized aluminium sheets. These were screwed to the roof structure. And the structure is mostly ready. We just had these props to keep the structure alignment in place. And then the concrete was mixed and poured into these holes. That and daubed. And on the third day, the structure was ready for the closing ceremony. So it was a very short exercise, very quick, and the structure was ready in no time. This is a little bit of treatment post workshop. So you can see that a bench was created inside and the roofing was properly fixed and everything. So that's how the bench is. And this is a prototype structure that we presented to the government. Next, I'm going to talk about another project that we did for a footbridge in Guwahati city in Assam. This was for the government, and again, this structure was supposed to be the gateway to the city, because Guwahati city is considered the gateway to the entire northeast, and this bridge was a symbol of that. So here the structure it's a steel structure, but has been used as a cladding, and the work was executed. The bamboo work was executed by Kanbu Kamesar's organization, and the workers did a fabulous job. This is the condition of the site when we were handed over, and you can see the steel structure was in place. And then we started cladding the exposed steel members with bamboo. And here you can see that we had welded joints. So all the connecting bolts were welded to the steel structure, and then the bamboo was accordingly was installed. This is how it came out to be. So after construction. There were some steel columns underneath the footbridge, and those were also cladded. So this is the cladding process in that showing, and this is how it ended up looking. It's a finished image with the lighting on. That's the detailing of the base. So there's the finished bridge on the day before the opening, and that's with the lighting on at night. There's an entranceway to the bridge. There's the side of the escalator that you can see. Again, like I'm reiterating that it's kind of the gateway to the northeast. So there's the escalator. There's the footbridge itself with the side claddings. That's the team. Here the purpose was to make bamboo popular among the in the public mindset, and I think this bridge has come a long way. It has been really successful. People have made this bridge quite viral on social media, and it's been widely spoken about on various print and electronic media as well. And it's a favorite hotspot for people to hang out, to take photographs and all. It's also a good space to host small art exhibitions and things like those. Then we worked on another footbridge in Guwahati. This is near the Sukreshwar Mandir. In Guwahati, here the concept was quite different, although we're using bamboo again for the cladding purpose. But here we got inspired by the temple, which was a strong context for us. So this is the Sukreshwar Mandir, and the way we started designing the cladding work or the bamboo design was based on various elements that we got inspired by, which are already there in this ancient temple. And here you can see some of the architectural elements that we picked up from the temple itself. And then we tried to reinvent them or to see how it can be done in bamboo or how it can symbolize something that's connected to the temple itself. So that's a sectional view. These are again some 3D views from the. And you can see these arches are very prominent, and they kind of symbolize the dome shape of the temple itself. These are, of course, 3D views. This is a picture from during construction. There's the cladding work going on the columns. And you can see this all this work was done while there was a lot of traffic like going underneath the bridge. So it was a very hazardous work to do. There's all the cladding work going on. And this is the team during somewhere around completion. You can see Kamishji right there proudly with his workers. But this is the day of the opening, and with the lighting and everything. And this was also like widely accepted. It became very popular, got a lot of media attention. These are some of the joineries that we developed. Again, inspired by the architectural elements of the temple itself. That's the Honorable Chief Minister of Assam. People found this place really photogenic. I'm going to talk very briefly about another workshop that we conducted for under the Green Skill Development Program of the Government of India. And here the purpose was again to reinvestigate the bamboo construction skills amongst the bamboo craftsmen of the region. And because there are a lot of there's a lot of bamboo craft that people do in Northeast India, but construction per se is kind of becoming not very popular with bamboo. So these craftsmen were kind of, there was a program of developing their skills in construction as well. So there's a structure that we built. This is the structure under construction by the workshop participants, and this was used as a structure with the roofing on, and there's a finished structure. Here again, bamboo was used for the wall paneling material as well, daubed with plaster, and bamboo mat boards for the ceiling. Again, this was a structure that was used for as a craft emporium to display all the craft items of the local bamboo craftsmen. It's also a demonstration structure for different applications of bamboo in construction. We were using whole bamboo. We were using split bamboo for the walls. We are using bamboo wood doors, bamboo wood flooring, and bamboo mat board ceiling. So different uses of bamboo in the structure. This is another structure that we did for the Rainforest Research Institute in Jorhat in Assam for a factory shed for their vacuum pressure impregnation unit. This is a bamboo structure that Kameshji built in Guwahati in a very short duration of time. So thank you everyone for your attention, and and thank you for giving me this opportunity to showcase some of the works that we are doing in Northeast India. Thank you, Kameshji.
Kamesh, you are in the mute.
Mr. Kamesh, please turn on your microphone. Thank you.
Thank you, Priyam, for your nice presentation, and I'm happy that you could showcase the work in Northeast that is happening in construction. Now I call upon the next speaker from Bali. We all know Bali is a land of beautiful temples and beautiful bamboo buildings. And here we have our colleague from Bali, who has worked in many capacities in all the bamboo projects that is taking place in Bali. So we hear from him straight away. Mr. Asar Saputra is a lecturer engineer with Gajan Magat University in Yogyakarta, and he's been involved in many of the projects since 2004 till date. You can name any of the good structures in Bali where Professor Aksar was involved, and so I just hand over the presentation to him and let me hear from him, because we are very fascinated by Balinese architectures, Balinese design, particularly in bamboo. So I would like you to speak more on how you have maintained the standards and all those things. Please, Professor Aksar. Yeah.
Thank you, Mr. Salam. I hope my voice is heard clearly.
Yes.
Okay. Thank you, everybody. It's a good honor for me, for Mr. Salam, and also the college from the Cheng University in Taiwan. Today, I would like to share my experience, also my difficulties during the construction of bamboo, especially for big building of bamboo. And also, before I start, I'm a structural engineer, and my presentation will be much more related to the structural or civil engineering aspect. So hopefully all participants, I don't know how many participants here who having a background of the civil engineering, because I think it's much more related to the structural engineering. And I will connect my presentation with the standard code, especially for the building code. And at this moment, for me, in my experience, difficult to fulfill all the requirement from the code to the bamboo building. I would like to talk about the bamboo from the beginning, and then I would like to talk about the concern on the some aspect related to the standard code. I will say about the natural period of the building, and also the story drift, flow, vibration, and then I would like to discuss about the limit state design. This is, I think, the core of the standard building code. I will not talking about the material itself, because already discussed by Professor Norman. So probably I would like to jump to the standard building code. Dear guests and all participants, let me start with the nature of the bamboo, which is very engineered from the very beginning. I will cite my Indonesian senior engineer that he stated the percent of the minimum material consumption is identical with the maximum accumulation of energy per centimeter cubic of the material. And this principle is very, very well depicted on the bamboo material. About the shape, about the cross section, about the separators, about the be very good to start from this point. And from this fact, I would like to say that it is strongly recommended to use original bamboo shape for the construction. In the consideration of material efficiency, cost, energy, and environment concern, for transforming into the rectangular section through lamination of pressed triangle movement. So I would like to request all the engineer or the architect, please to do design bamboo building using the original shape. If we try to utilize bamboo through the laminated bamboo and also the strand open pressed bamboo, I think it will not match with the requirement about the energy cost and the environment consideration. So let's start with the original shape. Originally, bamboo is already amazing, strong, and very, very, very good for the construction. So this is my opening for the understanding about the bamboo. Again, in number one about bamboo, I would start to request to ask the all audience to see the Bali Kite Festival. What can we learn from the structure of these kites? My question when I first saw this kite is that the craftsman or the artisan understand the modulus of the elasticity of the material because it needs appropriate stiffness or flexibility to make that thing flies. If too flexible, cannot fly. If too stiff, cannot fly. So it's kind of balance. It's kind of appropriateness about the mechanical and the physical properties of bamboo. So when I'm thinking about the code, so I'm thinking about the appropriateness. Should the bamboo come to the very standardized or it just come to the appropriateness? How about the bamboo building? Can we learn something from the situation? So this is also make me some kind of insight because after 10 years, 14 years dealing with bamboo, strongly it's hardly difficult to fulfill all the requirement of the standard building code. I will explain the situation case by case, but this situation bring me the understanding that sometimes the appropriateness is have to be fulfilled rather than only fulfill the requirement from the code. So what we would like to talk about standard building code in relation with the bamboo building, I will start with the design life. And then I will start with the fundamental or natural period of building. This is also, all these aspects should be taken into the account during the structural design. And then how about the interstory drift? And then how about the floor deflection and vibration? And how about the wind load? And at last, I would like to discuss about the limit states, which is include the ultimate limit states, serviceable limit state, and also durability limit states. So I think this is very, very challenging for all of us, especially for the architect and the structural engineer. This is the explanation about the natural or fundamental period of bamboo structure. Actually, many standard building code states or recommended the maximum natural period of building. The ICE 7 standard specifies that building are considered flexible if they have fundamental period greater than 1 second. Tall building or moment frame buildings tend to be more flexible, and also bamboo building because bamboo having lower module of elasticity compared to steel and also concrete. So it's probably very difficult to reach some kinds of appropriate stiffness based to this standard code. So in my experience, it's hard to obtain such fundamental period for bamboo structure. I will show you in my experience for the Sharma Spring building, 3 stories, and then I get the fundamental period is around 1.8 second. And then for the artist house, donors house, and everything, the more organic shape of the building and the more mass on the roof, and then it will be the longer the natural period. So this is the situation. And this natural fundamental period is related to the seismicity and also the wind situation in some region. So for the stiff building, the seismicity or the seismic load will play more important load. But for the flexible building, the wind will be the constraint. So this is the situation when we have to deal with the bamboo structures. So this is the situation. I will show you that if our structure is relatively cubical or regular, like the lodge in the Belgium 2011, you can see the shape of the building is much more regular, and we can get the natural period around 0.3. It's stiff building, and then probably not really affected by the wind load. But for the Sharma Spring in Bali, this 3-story bamboo building, it's also constructed in 2011. I got the natural or fundamental period around 1.8. So it is flexible. Sometimes if the wind blows relatively high speed, probably some sway will be happen in this structure. And for the artist house, we get more fundamental period due to the heavy mass on the roof system. So we get 2.5, and then this model this situation. So the engineer and also the architect have to give appropriate explanation about the situation, about the design and the natural period of the building. The last one, this is the example of the Nansha exhibition in Nansha Bird Park in Guangzhou, China. I think this is constructed in 2019. These pictures belong to WNA Studio, and as you can see, the fundamental period of this building is around 1.5. So this is the situation. So in this regard, once I say that it's difficult to make our bamboo building to become a stiff building, and sometimes the relatively big sway will be received or be seen in our structure. Number one is related to the design life or standard design life. One, this is the picture of the heart of the school, the Green School Bali, and this is constructed in 2008. So right now it's 14 years in service. In 2008, the founder of Green School, Mr. John Hardy, asked me how long this building will survive, how long the design life for this building. And then at that time, I replied that at this situation with the technological and maintenance method that we have, I will say that 25 years is the optimum points. And then Mr. John said, it's okay, 25 years is enough for the calculation of the economic aspect. Once we determine the design life, then this will be related to the earthquake load. The longer design life, the bigger earthquake load. And so for the wind load, and so for the snow load. Okay. And also for the durability.
你们看谁办的？
哦，陪伴。Sorry. Okay. So right now, in normal situation, the standard building code for the public space or the normal building, usually we will only have minimum 40 years design life. But I will say in the situation right now, I don't say it's impossible, but for my experience, 25 years design life will be appropriate in many aspects due to the durability, to the economics, and so on. So let's determine between the architect, engineer, and then the owner about this situation, about the design life. Don't give the information or misinformation to the owner that our building is designed to have service life, let's say 40 or 50 years old, because probably it will be difficult to achieve. The third one that I feel very difficult to fulfill the requirement from the code is related to the story drift or inter-story drift. In the normal situation or the common building, the code states the drift to be 1% or 1.5% or 2% related to the certain or the importance function of the building. Let's say for the hospital, probably the story drift only 1% allowable. But for housing, probably 1 or 2%. For office building, the code usually state 1.5. But in reality, probably it's very hard. Why? Because in this kind of structure, bamboo structure, the connection will play very important role on determining the inter-story drift. So the nature of bamboo, which having low MOD, 1/200 of steel or half of wood, this has become the challenge, how to get the inter-story drift not to be too high. And then the second one, the problem is related to the property of joint of the connection. So this is the challenge that I'm facing during the construction of this structure, bamboo structures. The next is related to the flow vibration or flow deflection. The vibration of the floor will be related to the strength, the capacity to withstand the load, and also the serviceability. Usually, standard code for the building will state that span per 400 or span over 300. But in this situation, when we design bamboo structures, span over 1400 is almost impossible to reach. And also span over 300 also difficult. Span over 250, I think this is the compromise point. Why? Because if we want to reach span over 400, then the floor beam will be very big. And the architect will say, I don't like this big beam. So at which point we have to compromise? So I will say probably span over 250 is the compromise point. So, but the most easier, and usually I will use this limitation is about span over 200. It's easier to obtain. I mean, the architect will agree, and then probably some vibration and little bit deflection. But the user also still okay. It's okay, no problem with this kind of vibration. When we're talking about the vibration, actually we will recommend, or in general, concrete or steel building, 4 hertz is the minimum standard, because when one stepping in the floor, this will be not be interact with the natural vibration of the floor. But with bamboo, try to reaching 4 hertz of stiffness. I think this is impossible. So usually we will only try to reach 1 hertz of floor natural period. And I will say this is acceptable once the user or the owner understand the situation. If we try to increase the stiffness, it means I have to put another beam or floor beam, biggest floor beam. So the architect also will say no, the user also will say no. So 1 hertz, I think this is the acceptable floor vibration for bamboo building. This picture is a Millennium Bridge at Green School Bali, already 11 years in service. Previously, at the same time, we saw the bridge constructed by our senior Yokstam, but after that, the bridge is washed away due to the flood, and then I called by the Green School to reconstruct a new one. And this is the calculation, and the situation is, I show you that sometimes we have to do arches and also the curve of the arches to be higher to get the stiffer floor vibration, or the increase the stiffness of the floor. Yes, this is kind of a challenge in structural design, how to match with some requirement of the building code. The next is about the wind load. I contacted with some client, some architect that having the design in the sub-equatorial region, which having the standard load more than 150 kilometers per hour. And when I come to the calculation and I beg to the architect, if you ask me to calculate more than 150 kilometers per hour, then I need, let's say, 6 fold of column. So what do you think? The structure will be very bulky. Then architect will say, no, it's too bulky. I don't need any light structure because bamboo should be light. So it's up to you and up to the owners. If I have to take into account more than 150 kilometers per hour wind speed, then your design will be bulky. So it's up to you. Then the discussion is come with the point of agreement that, okay, we can design with 150 kilometers per hour, but we will have to some kind of exit strategy, which is when the wind speed come more than the design speed, some part, usually the roof seating of roof cover will be let be blown away, but the mine structure will be intact. And then the user or the owner, okay, I can achieve that. So we can go for the further step for the design. Architect usually agree with it, but the user have to understand the situation about the bamboo calculation, about the bamboo properties and so on. So this is when we discuss about the wind load. Ladies and gentlemen, the next I would like to talk about the limit state design for the bamboo. So the limit state design approach considers that the structure should sustain all loads and deformation liable to occur during its construction, perform adequately in normal use, and have adequate durability. What the aspect of the ultimate limit state, about the loss of equilibrium, rupture, and so on, include fatigue. And for the serviceability limit state, it include the excessive deflection, excessive crack, excessive undesirable vibration that I already discussed with you or presented with you, and some kind of the special limit state due to abnormal condition about the durability, collapse, extreme earthquake, and so on, corrosion or deterioration or durability. So how we try to match the situation of bamboo with this kind of consideration? I would like to cite what already Anwar and Najam stated in the paper that yes, for the limit state design, usually we will play with the characteristics value of the material as a basic strength of the material, and also this will bring to the material safety, and then come to the design strength, and then we will put the member safety. At the other side, we will try to understand the characteristic of the load, and then we'll get the load factor here, and then we come to the design load, and then we come to the structural analysis factor. So this is kind of what in the evaluation of the standard code, I think we are here in the fifth step of the understanding of the building structure. We are talking about the introduction of the capacity design, capacity-based design approach. But for bamboo, as I explained previously, probably it's really difficult if we have to follow this introduction of capacity-based design approach. What I'm thinking or I propose, I think it will be more appropriate if we do the standard following the performance-based design and more explicit linkage between demand and performance. So in this sixth step of the understanding of the structure, the user, architect, and the structure have to come to one agreement. Which one is the most appropriate, the most desirable? So in terms of economic, risk, and everything, so then the design will become to the most optimum. So probably for the more advanced, the step number 7 probably will be sufficient also for the bamboo standard building, but I think the most appropriate is related to the performance-based design. One thing that we are not taken into account properly is about the connection or the joint on bamboo structure, which is play the most important role on the structural performance. It's how to get the standardize the performance of the joint, and this is will be affect very much on the performance of the overall structures. And how to include the connection aspect on this standard. If we talking about the material, fine. Professor Normando already explained us about this one. And then I think this become the ISO, Indian standard already have many, but when it comes to the all structures, I think it's not sufficient, or I think it's not enough. We have to do, we have to come to the another approach that in my way of thinking is about the performance-based design. I will explain about the situation about the performance-based design. This is the project that I involved in the development of community center in Buntoy, Central Kalimantan, funded by United Nations Office of Protective Services in 2012. At the time, UNOP sent the ARUP engineers to become a second engineer in service. To check my calculation, to check my design. After several hours discussion with the ARUP engineers, they said, how you very sure about the performance of the structure? Then we come to the very short discussion just to loading test. What do you want me to do? Do loading test. Okay, then we do the loading test. This is the kind of performance-based design. Sometimes the calculation not very clear, and sometimes it's not very sufficient for other engineer. So this is the way we can ensure that our calculation is sufficient. So this is kind of the loading test I do in the field at 48 hours loading both in the vertical and horizontal. This is for the uniform floor load. We do also, we will measure the deflection and so on. So this kind of calculation will be easy to understand for many engineer, for many region, because this is just very using the standard principle of engineering. So this is why I'm thinking about the performance base to check the performance, the structural performance of our building. We are not talking about the durability in this performance-based design. So the challenge related to the performance of structures is about connection, because this is again really hard to standardize, and then about the material deterioration to the climate. It is also how to maintain, and it is also have to be discussed from very beginning. The architect have to understand about this risk, about the material deterioration due to the weather. And sometimes, as the previous presenter said about the insufficient or sometimes inappropriateness method during the construction, about the workmanship, about the tool, about the how to avoid splitting, how to everything, because this is need some kind of very good process during the construction. So it's also difficult to standardize. Of course, compared to steel, compared to concrete, we have a very very clear standard during construction, but it's difficult for the bamboo structure. And at last, I think the yield material, I think they play the less role for the failure of the structure. So in my experience, I never see that the bamboo fail in terms of material yielding. So this is the less significant aspect when we are talking about the limit state design for bamboo structure. So in my conclusion that the design of bamboo structure shall be considered the comprehensive design life between owner and designer, and also we have to put the conservative side. Even though the catastrophe, the risk due to the failure of bamboo probably small because lightweight material of bamboo, and usually bamboo structure will have longer fundamental failure, more sensitive to wind rather to the earthquake. So I think this is a good point if we stay in the seismic prone area, and the approach for proper limit state should be more explored, considering the aspect of economic sensitiveness of bamboo material to the climate and the performance of joint and connection and so on. I think this is the setting situation for me, and thank you very much. And I will give back to Mr. Salam. Thank you very much.
Thank you so much, Professor Asar Saputra, for your intervention, which I think is very important, because here I have tried to combine practitioners, experts all together. All the views given are really very valuable. But when you say about seismic, my next speaker, Dr. Jagdish Bengala, has done his PhD in seismic on bamboo. I think he'll be able to elaborate more on the subject of seismic. And Professor Bengala has worked with me for the last 15 years, and he has a wide experience in bamboo in India. So all your knowledge and expertise are really going to help the bamboo sector, especially our collaboration with Taiwan-India collaboration, and with your support, I think we are really going to have a very good bamboo construction activities, whether in Latin America, in Brazil, or whether in India, or whether Bangladesh, or in Bhutan, or elsewhere. I think your expertise is really going to give inputs. Thank you so much, Dr. Sabutra. Thank you so much.
Thank you. You're welcome.
I would like to invite Dr. Vangela. In fact, he is also a doctorate in seismic. We talk about earthquake and all. I think I don't want to say much about his background. Dr. Vangela, please start with your presentation. Time is too short, and we have got two experts, panelists who will comment on your presentations. So, Dr. Vangela, please.
Thank you, Kameshji. Thank you for the Indo-Taiwan Forum. Let me share my presentation quickly.
Yeah.
Hope you can see my presentation. Okay.
Yeah.
So I'm going to talk about bamboo standards in India and issues and opportunities. So one very quick fact in regard with the Indian bamboos, I would like to mention that based on my last 15 years experience, selection and grading treatment plays very important role, particularly in India. Almost 70% of effort you should put on selecting, grading, and treating. 30% is involving in joinery, design, and construction. In India, common people consider bamboo as a temporary and undurable due to various reasons like limited natural durability, difficulties in joining, and lack of structural design data and exclusion from building codes. In 2005, National Building Code of India included bamboo as one of the building material. In Part 6 of Section 3B, it included bamboo as one of the building material. So today's topic is on standardization. So it is very much needed to accept as a sustainable structural material, both by designers and policymakers. Standards definitely provide a means to maintain, one is the product quality and then test procedures it will give. And it will also serve as a common language for defining quality and product safety. So initially we have like Indian standard methods for round bamboo and split bamboo. And then there is an absence of standard building code. As I mentioned, in 2005, they've included. So these are the standards we have, specification for bamboo tent poles, test for round bamboo, split bamboos, and then composite bamboo composites. We have a few standards, and also preservation and general glossary of terms, and also bamboo-based door shutters also we have it, and we have a National Building Code of India. I'll touch upon each of the standard quickly. So bamboo tent poles, this is IS 7344. It talks about the, initially we have like for tents and other things, for temporary structures, these poles are being used. So the specification of these poles are included in this particular standard, particularly for walls, standing and ridge portions. And for other codes like round bamboo and split bamboo, we have IS 6874 and 8242. These were revised once in 2008. Very interesting round bamboo, how to test the bamboo, very important. We have seen in Brazilian professor, his presentation to test the test also included in the code. This is how you will test it. So all these values were mentioned in National Building Code of India 2016. You can see various species, one in dry condition and another one is in green condition. All the values were mentioned in National Building Code of India 2016. And even the grading also done based on its structural properties, which were given in National Building Code of India. So very important point I would like to mention here is shear generally parallel to grain they have tested in the code. But we have tested a typical procedure wherein we have made a slit, and then because shear is a very, very important parameter in bamboo joinery. When you connect the different bamboos with nuts and bolts, shear is one very important parameter. This how this test was proposed for the shear test. The average value what we got is here. Typical ranges is from 4 to 11 MPa. So one very important test procedure we have developed, this is a free vibration test wherein you can create a fixity on one side, you can tap it on the other side. The natural frequency or the accelerometers we mount, and then we can measure the frequency. Based on that, you can measure the modulus of elasticity of the bamboo. And even the full-scale testing of bamboo columns are missing, and wherein we have tested single and double columns and various species data is required, because many of the architects or engineers, if they wanted to readily do it at the site, it is very important to have this information. And next is for split bamboos, typically moisture content specific gravity, static bending and compression parallel to grain was given in this particular standard. So the dimensions of the strips were given, like length is like 14 times the depth plus 5 centimeters. The dimensions were given in this particular standard. This is about the round bamboo and split bamboo. When it comes to the preservation, very important, as I mentioned, almost the construction involves preservation and then grading and then the construction. I'm coming to the second part, that is the preservation. We have IS 9096 and 1902. One is for structural and another one for non-structural. And we also, IS 707 gives a glossary of terms related to bamboo. So 707 gives you what is the basic definitions of bamboo clump and culm, and then also some of the bamboo joinery, joints, connections, and this was given in IS 707. When it comes to the IS 9096, what are the various materials one can use to preserve the bamboo were given, starting from coal tar creosote to boric acid borax to copper zinc naphthalene. So various preservatives were given in this IS standard. And also how much absorption a particular pole or a green bamboo or dry bamboo it has to take has been given in this particular IS 9096. And what are the various methods you have to follow, hot and cold, dip, diffusion, or brochery were given clearly in this IS 9096. When it comes to the non-structural purpose of the bamboo, IS 1902, they have given the modified brochery process. And also most of the non-structural purpose, either you go by soaking or by applying the preservative by brush coating. So this is the difference between the structural and non-structural preservative treatment. So when it comes to the composites, in IPIRT has done a lot of work wherein I have worked as a former scientist. So these codes were brought in particularly for the composites, starting from matte board to matte veneer composite to corrugated sheet to bamboo jute corrugated sheet. These are the IS codes were given. Typically, slivers were weaved into different weaving patterns, and then bamboo mats were made and then dipped into resin. This was subjected to a pressure and a temperature in a hot press. If it is a die is a flat, then you get a flat board, and then if it is a corrugated die, you get a corrugated sheet. Coming to the specification of the bamboo mat board, you have a number of dimensions that were given, different dimensions, and hot pressing I have mentioned. And the moisture content after hot pressing, it should be between 5 to 15%. And the temperature what you have to maintain is 140 degrees centigrade in hot press. And the pressure is between 1.5 newtons per mm square to 2.2 newtons per mm square. So the time also depends on the thickness of the board. These are the specifications that were given in the Indian standard for the bamboo mat. When it comes to the bamboo mat veneer composites, you include veneer, wood veneer in between. And then the slivers thickness is between 0.5 to 0.6 mm, and the width is 5 to 15 mm. You can make these veneer composite boards. Thickness varies from 3 to almost 25 mm. When it comes to the bamboo mat corrugated sheet specification, IS 15476, you can see the different dimensions and then the depth of corrugations and pitch corrugations that were given. So these were soaked and then again hot pressed, as I mentioned earlier. So these are the properties, requirements of this corrugated sheet, starting from the density to permeability to water absorption to resistance to fire. So this is the falling weight test, wherein 6 kgs, around 6 kgs of weight is dropped from a certain height, and also flame penetration. You give a flame and then it has to withstand, and permeability 20 centimeter depth water is stagnated on the roofing sheet, and then we will measure the is there any dipping. So these are the tests. These were the specifications given in IS for the Indian standard for the bamboo mat corrugated sheet. Coming to the bamboo jute composite corrugated sheet, you have two types. One is corrugated and then semi-corrugated, which was given, the dimensions were given. So this was given in the IS 15972. The jute, what you're incorporating, it should have a minimum of 220 GSM. That is the, the thickness, minimum thickness of the jute. And these were the requirements of the bamboo jute composite as per IS Indian standard. Coming to the National Building Code of India 2016. So there was a relation between moisture content to crushing stress was given. You have to season the bamboo to a moisture content of 20% and less, which gives the required strength to any of the bamboo. Freshly cut bamboo having a lot of moisture, like 60, 70%. So you have to season it. You have to bring down the moisture content to less than 20%. And National Building Code of India also gives the information about various truss patterns. One is with the, gusset plate, nuts and bolt, and also the regular pin-ended joint trusses. The information was given. It is very interesting to note that when you compare this solid bamboo pin with the mild steel bolt, which is connected to these members. So the solid bamboo pin having the 56% of the mild steel bolt. This was the information given in National Building Code of India. So various joinery methods were given, and also the treatment, how much, what are the chemicals you have to use were given in the National Building Code of India. And also the safe working stress of bamboo mat board and mat veneer composites were also given, and also how to protect the bamboo from the concrete using the steel tube were given in the National Building Code. This was the typical wall structure that was given, included in the National Building Code of India, cement mortar based structural walling system. Very interesting information was given with bamboo as the reinforcement and tiles. The thermal comfort inside the building is improved when you use the bamboo as a reinforcement or when you use the thatch roof. You can see the difference between a AC sheet to thatch roof with bamboo reinforcement, 5.47 to 1.69. You can clearly see the difference in the U values, thermal comfort values. So having understood the codes, some of the work, which is very important to know or do in particularly the performance of the elements. So element testing is very important. These are the cyclic load test, which has to be carried out whenever you are going for a different wall structure. So as a part of thesis, we have also conducted various element based testings, particularly wall framing, trusses, cyclic load tests, and so on. This was as a part of my fellowship. I have carried out the cyclic load tests on wall elements at Colorado State University, USA. So we've used actuator, and then we conducted in-plane cyclic load experiments, wherein the shear displacement, and as a professor from Indonesia was rightly mentioning about the drift was within limits when we numerically modeled the the house. So the seismic performance of the house is then given, wherein this was a part of my thesis. I have worked on seismic performance of the house, wherein you can see the building model was tested on shock table. Shock table wherein the pendulum is hitting the table. So here for the professor, as he mentioned rightly, like the fundamental natural frequency of the house is around 13 hertz. We have made the table such that the fundamental natural frequency of the table as 130 has 10 times more natural frequency than the building. So the tests were carried out on the building. I would like to show you a typical video wherein the test was, the carried out. The pendulum hits the table. We keep on measuring the various, the crack progress and so on. This was the crack pattern we have observed after the impacts. So some of the traditional based houses were also tested on shock table, wherein we could observe the the problems, and then we suggested the recommendations where to improve and which is the area one has to improve. This is very, very important when you are testing for a full scale models, particularly in the bamboo reinforced structures. So this was the shake table test. This I have already showed. This is the twisting of the house model you can see after the test. So it is also very important. New forms are coming up. These are to be incorporated in standards. Particularly, this is one student work I have carried out, particularly tensegrity structures, the foldable structures, wherein one has to work. This is a basic model. So based on this particular small model, we have actually numerically modeled a typical table, and then you can see the tensegrity structure. So this was initially modeled in Abacus, and then we understood the properties of these. So this particular table can be extended to a bigger structure like pergolas and other structures. You can see the view of this particular tensegrity structure. And reinforced concrete, we always have a doubt. Bamboo versus concrete, is it love or hate relationship? One has to understand. So some of the information is given in bamboo National Building Code of India, particularly the strength characteristics between mild steel, bamboo, and then concrete. So these values has to be upgraded because of the quality of the bamboo we are getting, and then the concrete quality also increasing. So this was the work. Very important, particularly when you're pouring the concrete, particularly for the reinforced bamboo structures, when you vibrate it, this entire skeleton of the bamboo will get disturbed. Self-compacting concrete is one such solution wherein you can pour the concrete, particularly for the bamboo reinforced concrete structures. And we have done one of the park bench using the bamboo as a reinforcement. And also with flat roof applications, one can use the bamboo as a reinforcement. You need to understand the behavior of the structure. So with that, thank you. This was one of the recent structure I have mentored in the part of the Goa. Thank you.
Wonderful speech and very valuable presentation. Let us really know how the construction limit and how it works. Thank you. Next, in order to promote the new international standard around the world and demonstrate the strategic value of bamboo, we have organized this forum and invite panelists from different countries to share their view. I would like to take the chance to invite Mr. Bueller Mahanavatis from the Australia, Melbourne, to share his view about this new international standards. Let's welcome Mr. Munir.
Hi, everyone.
Hi, hi.
Hello, can you hear me?
Yes, clear.
Oh, that's good, that's good. Firstly, I would like to thanks everyone for inviting me. It was really, really good to see all the detailed presentations around the bamboo standards. So as a background, my name is Munir. I work for a company called Giant Grass, and we have been working, designing and building with bamboo for more than 15 years. So I'm originally from India, and I started working with bamboo in India. Now living in Australia, I've worked and run workshops for a long time. The key thing I would like to highlight from today's presentations that I've noticed is that, it is really, really important if we want to sort of promote the use of bamboo on a large scale. Standards play a big role. Having good standards means it is easier for people to build with the material, and it also makes it easier for authorities to approve the material, and that will in the end result in the increased uptake of using bamboo. Bamboos obviously has, some people consider it as a poor man's timber, and it is also used for very luxury structures now for resorts and things like that. So standardization and having the right standards is quite important. If you would have noticed, most of the standards around bamboo are from so-called developing countries. It is still very, very tricky and difficult to build a bamboo building using, bamboo as a structural element in most Western countries. You can't easily build one. You can if you have, but you have to go through a lot of detailed structural analysis and processes. And that is due to the lack of standards in most developed countries around bamboo. I'm not sure if it was mentioned at the start, but there is, the new ISO standards for bamboo construction came out in 2021. And that is a huge step. Those standards are updated after a long time. And those ISO standards form the basis of a lot of these, round culm bamboo standards, and it brings a lot of other knowledge together in one place. I think that's quite important to note, because the more standards we have, it makes it much easier for people to build with bamboo. The other thing I would highlight from the presentation, it was really interesting to see, different people from different countries talking about standards in their countries, especially looking at the presentation from Mr. Saputara. I think he mentioned quite clearly around the limitations of bamboo. And that is very important to understand, because my background's architecture. I'm an architect. I like to design structures, but it is the structural engineers who actually make them stand. So a lot of the work that I have done so far has been focused on using the structural qualities of bamboo intuitively and then testing it further to make sure it will be suitable for construction. Mr. Saputara mentioned a bit about, so what are the key challenges and what are we willing to accept? So there's always a balance. He mentioned things about wind loading, the drift for the stories, etc. And you can see clearly that bamboo has its limitations. And like that, every material has its limitations. So it's very important to understand those limitations and design within those limits. Concrete has different strength, steel has different strength. They have different environmental impacts. Bamboo has, potential, it has lower environmental impact, but it has probably reduced life. For example, I was quite, surprised and also interested to hear that the lifespan that the Green School was built was around 25 years, which is slightly less than what you would normally expect a building's lifespan to be, which is 40 to 50 years. But one needs to consider the overall environmental impact of a material. Lifespan is only one thing. A building may last longer, but the material might have a longer impact. So thank you for all the wonderful presentations. I'll keep it short because I know people have lots of questions, and It would be good to hear some of those questions and respond to them. Thank you.
You can continue. We have kept the question answer by inbox only. If you have any more to say, you can just say. Yeah.
Okay, no, that's fine. I think, yeah. So, I'll maybe a couple of things in Australia, for example, using my work experience here. I've built some structures that have, that have been permanent, and we have done a lot of ephemeral structures, but Australia doesn't have any construction standards for bamboo. So we sometimes get a lot of people interested in wanting to bring or build bigger structures out of bamboo, like more permanent buildings. But then they get discouraged because there are no standards for bamboo construction in Australia. So what it means is, if you want to build something, you have to use external standards like ISO standards, or standards from South America, and then apply them. But you still have to test the bamboo poles separately to understand that the bamboo that were used there and the ones you're using here, they are equivalent. So that puts a lot of challenge, and it discourages people. So that's where I think having these kind of standards can play a huge role in use of bamboo as a construction material. The second aspect is how you use bamboo. I think it's most important. So, each material has its strengths and weaknesses, and understanding that and using that material to maximize its strength is very important. There are a lot of other sustainable natural materials. Bamboo is one of them, I would say. So there is, earth construction, there is cob, rammed earth, mud brick. Hempcrete is becoming quite popular. And bamboo is another awesome material, as everyone here is aware. What is important is to combine these materials to create a sustainable building. Using bamboo for everything is possible, but it is not necessary to use bamboo for everything, because sometimes other materials might do a better job, and in the end, it will give us a better outcome in the long term. Thank you.
Thank you, Munir. Thank you so much. And I hand over to Jack. I don't know whether Nipal is online. He's in Spain. He called me last night, but I'm not sure whether he is joining. In that case, I will request Dr. Jack to give his concluding remark. Then we can close after my remark. Or if there's any questions, if the public wants to ask, we can still have another 5 minutes.
Yes, we still have some minutes. Thank you for all of you to attend. And I think this is a very valuable and knowledgeable forum to let us really think about constructions which combine bamboo structures with the international standards. As my point of view, as long as we have the standards, we are more easy to duplicate or reuse the design, and then we can more popular to have more countries to using bamboo as a materialize to design and construct some of the constructions. Just like we saw the Mr. Kemash, their team, they designed the footbridge in the cities, which really join together. And also in Taiwan, we have the team which start to use the bamboo to build a bus stop, which also the other way, which we can really use to make the bamboo constructions with the public life together. And Kemash and I, we are build up one of the apps we call Bentech. The meaning for the Bentech is try to combine all the bamboo knowledge together into an app, which can install in the Android mobile phone, and soon will be can install in the iOS mobile phone. Let us, we can have more easy to reach the knowledges and reach the bamboo knowledges. I hope today's knowledge we will be try to combine together and put into our next version of the Bentech. And all of you, if you are interested, very welcome you to install the apps and share the knowledge to all the bamboo friends. Thank you.
Thank you, Jack. I think Nirpal is here somewhere. Nirpal, can you
Okay.
hear me? Hello, Nirpal. Hello, Nirpal. Are you online? Hello, Nirpal. Okay, I think he is having internet problem. He is in Spain. He called me this morning. Anyway, I would like to thank, starting from the Taiwanese counterpart, Dr. Jack and his team from CCU, then Dr. Bhaveso, the Vice Chairman, Vice Chancellor of Manipur Technical University and his team. Then I would like to thank our speakers from Brazil, Professor Norman. Oh, Nirpal is around. Yeah. Hi, Nirpal. Nirpal. Hello, Nirpal. Nirpal. He's in Spain. He has some internet problem.
Hello.
Hi, Nirpal, please. Yeah, Nirpal, please.
Yeah. Hi, how are you?
I'm good. Please give your comments. Nirpal. Nirpal, we are waiting for your comments, please. We can't hear you, Nirpal.
Esther Nipple, please turn on your microphone. Thank you.
Hello. Hello. Let's see. Hello.
Yes.
Yes, we can hear you.
Do you hear me?
Yeah, please.
Yeah. Are you waiting for my presentation?
Yeah, please do that. Please do that.
Yeah. Are you waiting for my presentation?
Please, you can speak, you can present, whatever. The floor is yours.
Yes.
Nirpal, you can speak a little better.
Okay. Okay. So you're. Yeah. So are you waiting for my presentation? Can I start?
You can start, please.
Okay. Just give me 2 minutes. Yeah.
Yeah. Nirpal is the founder of Abari, based in Kathmandu, but right now he is currently in Spain. I think he has got internet problem. However, Nirpal, your comments are very valuable for us. Please go ahead. Nipal, you are ready? Nipal, if you have a problem, you can just speak. They'll be better. Hello. Hi, Nipal. Anyway, while we wait for his presentation, I would like to take this time to thank Dr. Babeswar Tongbram, the Vice Chancellor, who is setting up a new campus, and he mentioned about using bamboo in the structures. I think there is a good step. And we have experts like Dr. Norman from Brazil. The work he's doing is very similar what we do in India. But what I can say is that the bamboo being used in Brazil, in India, or in other parts of Taiwan, or in Bali, the properties of bamboo different. In Bali, they use Dendrocalamus esper. We use balcua. People use gadua. We need the standardization, even looking at different bamboos. That is what I felt. And people are trying out different structures, different product out of bamboo, but again, the quality of bamboo is very different. While working out for international standard, I think this should be kept in mind of the standard of gadua or balcua or Dendrocalamus esper or mozo bamboo. This will also say a lot of word for the structures we do. I think it's very important that also I was very impressed by Kevin Royal's topic on the treatment of the boric borax discharge by using bamboo charcoal. I am very fascinated by his innovations of how to treat the waste using bamboo charcoal, so that the entire cycle of bamboo is taken care. I think Dr. Jack can look more into details of the Bamboo Charcoal Innovation Center in Taiwan. And what Kevin has said is very important. And Kevin is working very closely with the refugees camp, and I think he's heading to Poland for the refugees, for the Ukrainians, for the Ukraine there taking place. So bamboo plays a big role in the disaster management, immediate shelter. We also saw a lot of pictures of from Brazil, where the structures are made, using low-cost joineries. This is also very important. I feel that what can be looked into, not talking about much about what Bali is doing, the high-end ecotourism sector, the three-story buildings, the bridges, and this, these are, implications. So we see a lot of application from high-end structures to the disaster management, the refugee shelter, to the immediate shelters. So bamboo application takes place in a much larger way. But having said that, the discharge from the bamboo treatment, the chemical treatment is again environmentally, I think we need to look into this aspect. And Kevin's point was very well taken. Then Priyam spoke about the bamboo structures in Assam, in Guwahati, the structures. I think this is a good eye opener for the Indian market. So the Bangalore airport is now being restructured with bamboo, but those bamboos are coming from China. Having said that, these structures will take more of into more bamboo, looking at into round structures working in bamboo. Then we can also look at many other applications that is taking place in the country. Then we have Jagdish presentation on the seismic. This is also very important for us, living in a place where earthquake is very much prone to that. So this is very important that the seismic, and Jagdish worked more than 15-20 years on bamboo sector. So all this knowledge put together, I think we feel that sustainable development goal, what we look into bamboo, plays a very big role here, and I think this collaboration is taking a good shape. And physically, I think sometime we can have a workshop together with all the stakeholders once these COVID issues are, ease, I think, and we pray that things will be better in the coming months or years to come, so that physically we can have combined project with Brazil, India, Bangladesh, or in Indonesia and Nepal together, working in some common projects where all these technologies can be exhibited in physically, though we have the app, we try to upgrade this app so that all these technologies are available in the app, which we'll be doing by our lab in India or in Taiwan. But having said that, I see that lot of collaborations can take place where we all are working in the same line, in the same process. So I would like to again thank all of you for coming today on this event. So under this program, we plan to have 4 webinars, and this is the first webinar. The second webinar we plan in the next 4 months. The topic will be more interesting on carbon sequestration of bamboo, which is the in thing now. And Professor Norman has touched on this carbon sequestration, and I think this is one area where all the stakeholders can play a big role. Then we had the World Bamboo Day coming on 18 September. We try to have more physical and hybrid model. The plannings are still on. Then we may have the last event in the end of the year. So with these few words, Nipal is here again. Nipal, please, the floor is yours, and please speak for 5 minutes. Nipal. Just wait for Nipal. I think it's very important. Nipal.
Rupal, you have to unmute.
Okay.
Hello, hi everyone. Sorry, I'm sorry for the network connection. I'm traveling, so forgive my apologies. Can I start my presentation?
Mr. Nipal, please speak.
Okay, thank you. It's not letting me bring my presentation.
Nipal, otherwise you can speak if there's any problem.
As we are waiting for Mr. Nipal, we would like to invite everyone to take a group photo together. Please turn on your camera, but do not turn on the microphone. Thank you.
Hi, Nipal. I think we lost track. Hi, and Andre. Good to see you. Nipal, let me know. Otherwise, we will close in another 5 minutes.
Yeah, you can start with the other one, so I can maybe join in a bit.
You are the last. No problem. You're the last. We are waiting for you only.
Okay, okay. Because it's not letting me share anything.
Kevin, please kindly have a look.
Kevin, can you send me what is the code?
So you can use the share button below.
It's not letting me do that.
Okay. Or can you email me? Or to...
Yeah, I can email it to you.
Or to Kevin immediately, he can play for you.
Okay, that's...
While you email, you can start speaking so that, we don't waste more time.
Okay. Yeah, thank you again. And so sorry about this. This is... it's very frustrating. Just... Yeah, I will... Today, I was going to talk about my experience with working in bamboo after the earthquake. In Nepal, we have, according to the last census, we have 74% of our construction in the whole country is built with natural material. And if it's natural material, mostly 100% of the time, or close to 100%, the roof or any tensile member of the construction would be with bamboo, or timber, but mostly bamboo, because timber, people do use timber, but in the mountains, the timber are not long enough that people use bamboo for construction. And and also people use reinforcement with bamboo. And so there's a big tradition of using bamboo in our country. So according to the data, like 2/3 of our buildings has one or other elements of bamboo. But the problem is these materials are considered in our context in Nepal as what we call katsa material or temporary materials, right? So, we have like tradition of treatment of bamboo, using water treatment, soaking, leaching, and smoking. And using this technology, people have made bamboo structures that have lasted more than 100 years. But unfortunately, it's considered a temporary structure. And also the thing is, but that doesn't mean that you are not allowed to build with it. You can build with it, but you don't get bank loans or other recognition from the government. So after the earthquake, before the earthquake, I had been advocating use of bamboo, especially for the roof. If people don't want to use everything bamboo, that's fine. But if they use bamboo for the roof truss, it would definitely be very helpful, because bamboo is ductile, it's elastic, and even if there's a shake, it will not. Even if it fails, it's not heavy that it's detrimental to health of the people who are living there. So with this concept, I'd designed a small public school, like a 3 classroom, using stone on the bottom and bamboo as a roof. And then we had a stone slate. It's very insulated. It was very well designed. But it took a long time because, to get the permission, to get the recognition, to get the funds. And it took, after 3 years, we built the structure. And interestingly, what happened, that building we built lied at the epicenter of the earthquake. And so interestingly, that was the only building that survived in the whole district, So all of a sudden, from a very fringe material, people started talking about bamboo. We got like good coverage in the media, from international media. There was a BBC did a nice report on us. There was on Al Jazeera, like focusing on how there are alternative ways of building. Not all traditional constructions are weak. So that gave a really big momentum. So with that credibility, we went to the government and said, hey, you have to build 10,000 schools. After the earthquake, there were like a lot of damages. So, and I proposed, why don't you use bamboo as the material for, you can use other materials, but just use bamboo for the roof, because a lot of heat loss happens through the roof. And the most expensive part is the roof. So why don't you use bamboo? And it's, available everywhere. There are a lot of reluctance, but some districts did allow us to prove, again. So after the earthquake, we built about 25 schools. By the way, Kamesh, I've already sent the presentation. So I sent, we built about 25 schools using bamboo, and we made this whole design as open source. So meaning anyone who is interested can download the design and use it, right? So we have hundreds of downloads. We just prior to, apart from traditional schools, there were a lot of transitional homes that needed to be built. And there were about 10,000 transitional shelters that were built using the open source technology that we gave out. So what we did was made very simple, in terms of standardization, you cannot, bamboo, as we know, it's a very homogeneous, heterogeneous material. It's not perfectly round. It doesn't have, you cannot be standardized, but something that can be standardized is the joint. So we did a lot of testing on the joint. We had a small metal joint. And so it was slightly bigger than, let's say the diameter of bamboo is 80 centimeters, most of them. So we did about 90 centimeters.
To you. You can just open it. Yeah.
So, so about 90 centimeter. So this way the joint became standard, while the rest of the components were like in its raw form. So using this, it was a very successful movement, I should say. And so many people build a transitional homes, schools, about 25 schools were built using this technology. And also we gave for regular homes also. But from our experience, what we found out is people are very reluctant to make their own homes with bamboo. And one of the reasons is nothing to do with the material. It's because of craftsmanship, bamboo is, you need a very skilled person, like if you work with timber, you're working with a fixed geometry, there's 2x4s or 4x4. So there's a fixed geometry that you're working with. But if you're working with bamboo, it's round. So craftsmanship was a bit difficult. But as in a whole, we try to make that little bit more accessible by making that joint part with metal. And using that, we were really able to scale. Oh, great. Yeah, so as you can see, these are like the documentation of all the traditional bamboo homes in Nepal. So even if it's earthen homes, usually the truss, the beams are always made with bamboo, right? And so also the other thing they do is when they do wattle and daub, they flatten bamboo and then do mud plaster over it. And mud plaster, what it does, it sucks the moisture, and so when there's no moisture, there's no insects. So that's the traditional way of treatment. So you even like the house, you see all the truss members, the beams, are usually made with bamboo, and the outside version they use timber. Next. So yeah. So just stop there, please. Next. Yeah, so this is a very typical timber and bamboo house. You know, like the outside, the columns are timber, but the inside, everything is bamboo. You know, it's wattle and daub. They do multiple stories also, up to 2 stories. And also one of the tradition, like please leave it here. This is a bridge that we had a big tradition of building in Nepal. This is about 30-meter bridge, and the photo is from 1895. You know, it's a bridge that's connected using rattan, and it has a very similar concept of a modern suspension bridge. But unfortunately, we have lost this skill, you know, because this was never encouraged. Here's another bridge from Nepal and Sikkim border. So this is more using rattan and bamboo as the structural element. And unfortunately, we have forgotten that technique, and this is the typical bridge now people are using in very remote areas. Next. So this is the census data I wanted to show that around 74% of our constructions are still using traditional material. And as I said, and in some areas in Midwestern Nepal, the level of cement penetration is only 0.2%, not even 2%, 0.02%. Yeah, can we go next? Down. Down. Yeah. So we can go down and like actually the word Kathmandu, you know, like I come from Kathmandu. Kathmandu means Kath means wood, and Mandu means the place. And so traditionally, everything was made with timber. The whole city was built with timber. But unfortunately, we have lost that tradition. Now it's become cement Mandu, you know, cement structure. Go next. And it's unfortunate because Kathmandu has the world's largest amount of a world UNESCO heritage site, and most of them have timber and bamboo in their joining. And so there's a false narrative that's shown by the government that cement will be very strong while bamboo will collapse. But I did a very intense research in the epicenter, and we found out that 90% of the concrete buildings collapsed, while properly designed timber, bamboo, stone structures survived. Next. Next, please. Yeah. Next. I will not. Next. Next. Yeah, I'll not talk much about bamboo because I'm talking to the expert, but I want to show a few technologies and the innovations that we've used. One of the major innovation was the boucherie treatment. You know, we hacked a very simple system using a cylinder and a bicycle pump that we would take to the mountains. You know, we don't have a huge plantation of bamboo, and whatever bamboo there is, it's out scattered in the world. So using this boucherie technique, you can go, the person would charge very nominal amount and then join and then treat it. And the second one was joint. This is the one I was talking about. The next one, please. Next one, yeah, please put it here. So here, the structural joint, yeah. So we did a very simple bracket, a steel joint. So this way, as I said, you don't have to standardize the bamboo, but at least you can standardize this joint. You know, most of the failures, as we know, happens in the joint. So once we have a very strong joint that can accommodate different diameters and sizes of bamboo, it made the construction much easier. So our in the beginning, our primary focus was to convince people to use in the roofs. Here's one of the public halls that we did. We said, okay, use whatever wall system you want, but make the bamboo roof. And so this is the school that I was talking about. So we use the traditional stone for the walls, and for the roof we use bamboo. Can you go next? Yeah, so please stop here. So this is so we did a very properly designed truss using the metal system, had a lot of cross bracing and a small opening for ventilation. And we did a nice plastering with earth. And this was the building that survived the earthquake. It was at the epicenter of the earthquake. It was not, it was 7.8 Richter scale, and this was at the epicenter. And so, as I said earlier, this was the building that gave us credibility, that helped in jumpstart our construction project. After that, we proposed to the government, to use in their traditional school building bamboo as a construction material, at least for the roof. So we can we go next? So here, please stop here. Yeah. So here's the roof you see is bamboo. It's insulated with bamboo mats, and then we have a ventilation, a thick wall for thermal comfort, and we did mud plaster over it. There are a lot of niches. So like with the same budget that they were building for the traditional schools, we proposed with bamboo. Next. And so this is one of the schools. As you can see, the roof part is bamboo. It's very well insulated. You go next, please. Yeah, no, please stop here. No, yeah. So yeah, the roof is bamboo. As you see, the metal joint is, the joints are metal. They're like very highly insulated. Even the furniture are bamboo. We even put a whiteboard in the furniture. So bamboo is, the furniture being lightweight, people can move around, that space becomes flexible. So this was an open source document that we put on our website, and people could download it. And using this, as I said, more than 25 schools were built. Even now it's getting built. And one of the most interesting part of this construction is the 89% of all the construction cost stays in the community, right? So it's not going outside. Only 11% goes in building, buying other materials. So after the earthquake, and it gave us a lot of momentum. So we built libraries, like public spaces, because that's where we found the need to be. In private homes, people are a bit reluctant. They'll be like, "What will my neighbors say?" But in public spaces, there's more acceptance. So we built this huge public library right in the center of the city in Kathmandu. So we use a lot of traditional elements. We use mud on the outside. On the outside, we try not to expose bamboo. Even though we treat it with pressure treatment, we understand it has certain limitation, because we use borax, which is a water, can be leached water. So we use it in the interior, right? So we did this public library, we built more credibility with that. And after that, we started getting more projects. So so here's some of the typical truss element. So we built another school. It's an orphanage. We use everything like you see behind. There's a bamboo forest. We just took went there, got the bamboo, and built it. Next. Yeah, so you can see like a lot of elements are bamboo elements. Huge span structures. Like that's the beauty of bamboo. its strength and its flexibility and its localness, right? So here you see all this, the walls are built with bamboo. The reinforcement is bamboo. The inside truss is bamboo. Yeah, if you can stop here a bit, this is a typical truss. You know, we designed it such that it works as a truss as well as a jungle gym. So you know the kids can come and like climb on it. You know, it has a pretty big span of about 9 meters. Yeah, so a lot of elements with this, you can see. So as you can see, we're not very reluctant to use bamboo with other materials, you know, in order to get the strength that we need. So here we have used I-beams because the span was pretty big, but then we use bamboo for the joist, you know, which, so we're using materials for its proper, like using it judicially where it has the best properties. And next, yeah. So as what I'm really happy to say that in Nepal, you know, I've been working for about 12 years now, and the first 3-4 years it was very difficult because of the acceptance, but now slowly people are accepting. They're building their homes, they're building their we are building now a monastery using this material, which shows that you know, and we are building public places, hotels, and private residences. So it's showing that you know, there's acceptance. And just to stop this slide, finish the slide, what can you, yeah, stop here, please. So we have also created a backward linkages, you know, so we have, as I said, the bamboo in Nepal is not, we have a lot of bamboo, but it's not done commercial plantation. So we did a project where we took degraded land, like this land, you know, there was a flood and it was degraded like this. So, and then we started planting bamboo. Can we go next? So one on the left is after the flood, and one on the right is after the bamboo plantation. And we've helped in training that river. And in 8 years, it's become very vibrant, well-trained river. Like you see, in 2001, this is the river. Next. In 2005, it started moving its course. Next. And 2010, there was a big devastation. All these white spots are, you know, the area where the water went. Next. And 2014, we you know, it started by planting bamboo along the river. And 2018, it's become like, you know, there's now a vibrant ecosystem. Yeah. Next. Yeah, so thank you so much. So this is what we wanted to show, you know, like we even making the bamboo bicycle. So in the streets of Kathmandu, if you can sometimes see our bamboo bicycle. So we try to create a whole ecosystem by bringing in communities and you know, creating a small industry that's good for the people and for the planet. Thank you. And again, my apologies for the delay. Kamesh, I think you are in mute.
Thank you, Nirpal. With your presentation, I think our day was completed with the bamboo structures. And really happy with your work and what you are doing. And I think it's a very good global connection we are doing on bamboo construction. We look forward to working in physical very soon so that we can all combine our strength together for bamboo construction. Thank you again. And I would leave to Dr. Jack to give his concluding remark before we close.
Thank you, Nipo, and see you again for your bamboo school, which always amazing for me to see the elementary school they can use in the bamboo as roof and the beautiful all the constructions. And thank you all of you to attend and for the forum. I hope And our next forum, you are still joined. We hope we can share all the bamboo knowledge to all the world friends. You are love bamboos. Himash, next for you.
Thank you again. I think we close this event for the day. And we will be having this in YouTube and many other forum. We'll be sharing with all the participants. Thank you, everyone. Thank you, all the speakers, all the panelists who are here for the event. Thank you so much.
Thank you and all.
And I hope there are a lot of questions to be asked, and I'll be happy if you can post the questions to us for us to reply back to you. Thank you, Jagdish. Thank you so much for your good work.
Thank you. Bye-bye.
Thank you, sir. Thank you.
Bye. Bye.
We have come to the end of today's forum. Thank you for your participation. Next time, the forum will be held on 13th of May.
Thank you.
At the end of this forum, through our protracted and unremitting efforts, we are pleased to inform you BAMTech Bamboo Learning app has been launched in Google Play Store, which is designed by Center for E-Manufacturing and E-Commerce, National Zhongzhen University, Taiwan, and Center for Bamboo Initiative, National Institute of Design, India. With South Asia Bamboo Foundation, India as a knowledge provider, we believe this app will bring bamboo technology affordable to the bamboo community as India-Taiwan cooperation on bamboo. We sincerely welcome you to be part of our international collaboration. You can download the app through scanning the QR code. Thank you.